Hello, Mr. Prakash.
Hello, good morning. Good morning.
Good morning.
Yeah, good morning. Just waiting for me to get access to share the screen.
Sure, no problem. Thank you so much.
Thank you.
Hope you had a good weekend.
Yeah, absolutely.
I'll just be here on standby.
Okay, thank you. Right, I guess most of us are already here, and we can get started just to make sure that we can complete the topics. We can't further delay it. I think we're starting a little late. Any which ways, I hope I'm audible to everyone.
Yes.
Yes,
Yes,
sir.
yes.
Perfect, perfect. All right. So today's going to be more of the test and all. We will be the final session. We should be covering all the remaining topics. To get started, we will be talking about hypothesis testing. Once we have completed the measure phase, we have got the required data. We have to perform the statistical tests to find out which one out of those possible causes, like this spreadsheet, which is my problem is the ticket closure time. My management wants me to reduce the ticket closure time because there's too much of backlog with whatever may be a business problem, revenue, cost, quality. That's your why. All these are the factors that you have possibly thought, like this is my possible cause because of which I am facing the problem. So during the fishbone diagram, you kind of can like brainstorm and found possible causes, and you then collected data around that why. And when this why happened, what was the value of x's? Say, for example, this ticket closure time, a ticket was opened, who handled it, what was the gender. So you kind of fill in all the details, like what kind of ticket was that, what was the CSAT score that we got on that ticket, how many follow-ups were required to close the ticket, so on and so forth. So we would have collected this data. This spreadsheet is ready now for analysis. All we're trying to find out is that if we believed that these are root causes, which is why I'm facing the problem. If these root causes can be fixed, my business problem will be sorted out. Now, the first question we would like to understand, is it the real root cause, or is just probably we thought it to be one? So we would like to use the statistical test and analysis to find out, is it the real root cause? And that's where the hypothesis testing comes into picture. Now, whenever we're going to start, like, so I have, what I did is just to kind of save on time, I've like pasted this entire material from the previous session. So we will save on the time of typing and all. I'll just walk you through and I'll kind of parallelly perform all these tests. So let's start with this. Once you get your data collected, first thing first, we will be doing normality testing. We all know what is normality testing. We've done the normality testing before, but still we will do it just to get started. So let me just copy paste the entire data sheet. And that's how, like, that should be the process, how we should go about testing everything from here on. Once your data is collected, once you calculated your sigma levels and everything, that's where we start. Uh, your data is ready. So let me just go back to the sheet. Okay. So first thing first, we would like to check whether the business problem, the data Y, is that normally distributed or not. So we perform the Anderson-Darling normality test to check whether the business problem, whatever problem you're dealing with, is that data normal or non-normal. Now, basic definition, just to kind of quickly recap, because that's what we'll be dealing with. Null and alternative hypothesis that we discussed in the last session. Null is a default hypothesis. An alternate is the claim which says, no, null, you're wrong. That's how it is. Null will always talk about equal to that. Say, for example, we're comparing the productivity of morning shift versus evening shift. We're comparing the productivity of male versus female. We're comparing manager A performance versus manager B performance. When we're comparing the averages of two different groups, or more than two groups, also for that matter, like if we have five managers, we want to compare the performance level of all those five managers. Null says all the managers are same. There's no difference between them. Alternate says no, there is someone significantly better or significantly bad. So there is a difference. No, all managers are not same. So null will always talk about equal to. It will always say good stuff. Alternate will always have a claim to prove that no, this is not right. Somebody is better. Somebody is bad. It will always be the claim that we make. Whether null is right or alternate is right, we will get to know by the p-value. And that's just the thumb rule we have to keep in mind always whenever we're dealing with any statistical test. This is what we have to keep in mind. When you perform any statistical test, it will give you a p-value. If that p-value is less than 0.05, that means your claim, which is alternate, has been proven. You wanted to prove something. Yes, you are successful in proving that alternate is right. But if your p-value is equal or more than 0.05, then you will say no, null remains true. Null is a default hypothesis, default understanding. So we wanted to reject null, we wanted to accept null, alternate, but we failed. Null still is true. So null will always be true unless you prove it wrong. So at this stage, say, what will be my conclusion? The way I write it will be, we reject null and accept alternate. So that's where when you have p-value less than 0.05, that means it's a validated root cause. You have been able to prove something. When you get a null, that means your p-value is equal or more than 0.05, you will say that we failed to reject null. Null was right, we wanted to prove it wrong, but you failed. So that's where you will just keep this in mind. Never say null was proven right. Never say that. That's rest everything. You can write it in your own words. Never say that null was proven right, because null was always right. Null is a default understanding. So null was always right. You cannot prove something right, which is already right. So that's how we will keep, we got to keep this in mind. Rest everything is your choice. You may frame it in any different way, but just never mention that null was proven right. Yes, you got p-value, which is more than 0.05. You'll say that you wanted to reject null, but you failed. Bottom line, null stands true. So with respect to normality test, what we're trying to prove, these are default hypotheses. Null means with respect to data normality. Null is always, that data is always normal. Any data that you have is always normal. Alternate will have a point, no, 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 this data is non-normal. So yeah, we would like to perform a test, which is Anderson-Darling test, and understand whether it's normal or non-normal. So just to do this test, we go back to the stats, basic statistics, and we have two options. Either we do a normality test here, or we can see it from the graphical summary. Let's kind of check it out from normality test. Ticket closure time, that's what we want to check. And here it says test for normality, Anderson-Darling. We click OK, and let's see the p-value here. Okay. It's taking a bit more time than usual, any which ways. Okay, we get a p-value as 0.587. 0.587 is the p-value for Anderson-Darling normality test for this data. 0.587, let's bring it back, 0.587. That is null. It's more than, unless and until it's less than 0.05, it is going to be null. So this is null. Null means the data is normal. So we had a claim, we wanted to prove no, the data is non-normal, but we failed. Why? Because the p-value supports null. P-value confirms that the data is normally distributed. We wanted to prove it's non-normal, but no, the p-value doesn't support that. So we failed to reject null. Hence, we know the data is normally distributed. That's how it is. I hope this is clear. We'll just kind of keep checking. Is it clear to everyone, the null and alternative? Because
Yes, sir.
perfect, perfect. So now I know my data is normal. So data is normal, that's once done. The second thing we must always check is the data random or not? And now what's the definition of random? We will understand that. But to check the randomness of the data, we use the test called run chart. The name of the test is run chart. Now, similarly, again, people also call it as randomness, or you can say stability of the data. Meaning is same. So you can say either randomness or stability. Now we use run chart test for that. In case of randomness also, the default definition is data is always random. Null always talks about good stuff. Alternate will say no, 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 data is non-random. Now how do we check it? Again, let's perform the test of run chart and see whether data is random or non-random. And then we'll understand the meaning of random also, because that will be required. So this data is here. I would like to check if this is random or not. So stats, I go to quality tools, and the first chart is run chart. Stats, quality tools, and then run chart. So I select this data, ticket closure time. It says asking for subgroup size. Now subgroup size is 1 because it's collected in a single column, one data at a time, one data at a time. So default generally it's always 1. Subgroup size 1. Click OK. Now that's how your run chart looks like. Again, different depending on data, but all in all, what we're looking for in run chart, what is this randomness factor? Uh, uh, I didn't get it, Brian. Is there a
So
request?
sorry, sir. I
Okay,
have
okay,
I'm trying to join using
okay.
my desktop so I can
Oh
transfer.
no, that's fine. That's fine. That's fine. So,
Thank you.
okay. So shall we resume?
Yes, please.
Okay, please. Okay. So
Uh,
now, when we talk about randomness, what we look for, again, there are 4 types of patterns. When we say randomness, what is the meaning of randomness? Let's understand this first. If the data has no evident patterns, there are some patterns in a data. In a data, you can find 4 different types of patterns. Any data can have, not necessarily. You can have 4 different types of patterns. If any pattern is available in the data, then you say the data is non-random. A data which is free from patterns, no patterns. If data has no patterns in the data, it is random. And there can be 4 types of patterns. So if the data has no patterns, I'll say the data is random. Even if one pattern is also available, I'll say the data is non-random. What are those patterns? The name of the patterns is clustering of the data, oscillation of the data, mixture of the data, and trend of the data. Now, these are 4 types of patterns which can be present, not necessarily. They can be present. If any one of these patterns are present, it will make it non-random. If the data is free from all these patterns, it's random. Even if one is present, it will make it non-random. How would we know? Again, p-value. If any of the p-value for these patterns, we'll get 4 p-values. P-value for clustering, p-value for oscillation, p-value for mixture, and p-value for trend. All these patterns will have p-values. Any pattern which has less than 0.05 value, that means that pattern is in the data. That confirms the presence of that pattern. So let's have a look at the data. P-value for clustering, this is not less than 0.05. P-value for mixture, this is not. P-value for trend, and p-value for oscillation. All these p-values are more than 0.05. This data has no patterns. This data is free from patterns. This is a random data. Let me show you another data just to kind of give an idea how uh, non-random data would look like. So see, have a look at this. P-value for clustering, this is less than 0.05. So this confirms that there is a clustering pattern in the data. So yes, this data is non-random. Mixture is fine. Or trend also is there. So we have 2 patterns in this data where we have clustering issue, we have a trend issue in the data. We don't have a problem with mixture. We don't have a problem with oscillation. So look at the p-values. You have 4 p-values. If any single p-value is less than 0.05, that means the data is non-random. So here, now when a very basic question can come into mind, that I know that why did we do this normality test? Because we wanted to know data is normal or non-normal. Why? Because if it is normal, I look at mean or average of the data. And if it is non-normal, I would look at median of data. So that was the purpose of doing this normality test. What is the purpose of doing this randomness? What does it help me with? There is a reason why we do this normality randomness. Is there are certain statistical tests which we'll be doing in a moment, right? First, there's a test by the name of Anova. We will be doing this test. If you want to do this test, if it's required to do a Anova test, you can only do it if your why or if your business problem is random. You cannot do ANOVA if the data is non-random. So in case the data is non-random, you need to replace the test of ANOVA with Kruskal-Wallis. So we'll look at all the test name and everything, but keep this in mind. ANOVA is a sensitive test. It will only be performed if your business problem is random. If it is non-random, then you have to change the test and you have to use a Kruskal-Wallis test. That's a different test. So yeah, practically that's the need of doing a randomness test. Once we have figured that out, like in our case, we had data which was random also. We have checked the data ticket closure time is random, and this is normal also. Pretty much we're good with that. So always perform these two steps, and then we get into the actual testing of the data, X and Y, and all that testing, all these X's that we have collected. We'd like to start test. So when you look at the data, you have two types of data, like X's, the factors that you collected. Some X's are numerical X's, some X's are categorical, which is text-based X. So let's have a first look at this numerical and categorical X's. MINITAB, look at this. MINITAB automatically identifies the data as a number or a text. This is your Y. It is all numbers, so it is C1. See, look at this text, it becomes T. Text T. Alphanumeric text, text T. See, this is all numbers. It remains C6. All numbers remain C7. So whenever you have the data is identified automatically by MINITAB as a number or a text, as a number or a text. So whenever you have X's which are number based, you will be doing the test by the name of correlation. That's the name of the test, correlation, that we will be performing to check whether that X has an impact on Y. Is it a root cause or not? We would like to perform a correlation test when the X is number based. So along with the test, there's will be a graphical plot, which is scatter plot. This is one of those 7 quality tools I said that we will be using when we conduct this particular test. So correlation will always go hand in hand with the scatter plot. So we learned when we perform the correlation test, we'll be seeing a scatter plot along with it by default. So these two tests will, like, one is a graphical test, another is a statistical test. They will come all together as a single unit. Coming to the other X's, which are non-number, non-numerical, which is categorical. Within that categorical X's, you will have some X's which will be two grouped, and we'll look at that first. And then there are two plus group. Let's have a look at this first. What is the two group and two plus group? I'll go back to Excel too, so that I can show you what is two and two plus, because that's, see, selecting a test is more important. Knowing which test needs to be done is more important. Doing it will take only 2 clicks. That's what. So just got to keep in mind when to use what test. Say, I have data of Jaya, I have data for Nitin, I have data for Ravi, I have data for Vandana. So these are my 4 ticket handlers that I have. So I am comparing data for 4 different groups. So this is why it's 2 plus, it's more than 2 groups, 2 plus group. So that will be, ticket handler will fall into 2 plus group. Gender, male or female. So I have data for male or I have data for female. This is 2 groups. Ticket handler age group. Again, we have data for under 20, more than 30, between 20 and 30. So there are 3 groups which will fall into 2 plus group. Ticket type. So either I have a hardware issue or I have a network issue. Again, 2 groups. So data in categorical format will either be a 2 group or it will be a 2 plus group. Whenever you have 2 groups, the name of the test is 2 sample T test. The name of the test is 2 sample T. So like when we're comparing gender, I will be doing a 2 sample T test. When I'm comparing uh, ticket type, I'll be doing a 2 sample T test, because I'm comparing 2 groups here. Whenever there are 2 groups, I'll do a 2 sample T. The way we have a graphical test as scatter plot here I will be using a box plot for, this is statistical test, this is graphical test. Whenever we have a 2 plus group kind of case, like we talked about ticket handler, we have four groups, it will fall into 2 plus. When we have ticket handler age group, which is 2 plus, so I will be doing an Anova test. That's what we were talking about, Anova. What if in case your Y is non-random? So instead of ANOVA, you will be doing a Kruskal-Wallis test. And even for this, the graphical test will be a box plot. That's how we need to perform the statistical test, which falls into this particular section. We know this pretty much. We know the analyze phase. That's how simple it is. But just want to make sure that yes, we don't end up selecting wrong test, because it's that will kind of it would not be the right thing to do, because it will give you incorrect inferences. That will not be the right thing to do. Now, first thing first, let's kind of start with the categorical one, and then we'll move on to this one, because this is some more additional information in there. So when we're talking about two groups, let's compare two groups, do a two sample t-test, and let me explain how it's done, and then we'll move to 2 plus, and then we'll go to correlation. So let's find out 2 plus group, which is two groups, which is two sample t, like gender. Now, what am I trying to compare here? I'm trying to say that gender wise, null says male or female, your average ticket closure time is same. So female ticket closure time average and male average of ticket closure time, that's same. Alternate says no. There is a significant difference between male and female. Either male is doing exceptionally well or they're doing exceptionally bad. They are this practically male and female. They are performing at absolutely different levels. So let's understand whether it's right or not. Probably somebody was gender biased, wanted to say probably male is better. Somebody wanted to say female is better. We don't want to have any preconceived notion. Let's perform the test and find it out statistically. Is this a real root cause? So you go to stat, basic statistics, and we go down to two sample t. Stats, basic statistics, and then two sample t test. We click on this, and let's, okay. So samples, this is where I'll put my Y. So I click in this box. I'll get ticket closure time. I'll say select ticket closure. Sample ID will be my X's. So I have gender of the ticket handler. So Y will come on top and X will come at the bottom. Samples will contain my Y. Sample IDs will contain my X. I'll click OK. That's it. That's what is required. The test is done pretty much. Let me kind of explain how to interpret and read this. But before we do that, let's first look at the p-value. Can you tell me, is this null or is this alternate? Anyone? Null or alternate?
That is alternate.
Absolutely right, 100%. This is alternate because p-value, when it is
Is
less
less
than,
than.
yes, 0.058 is alternate. Hence, we have a validated root cause. Yes, somebody, like, so whoever was, I was saying gender biased, not is not a person is not gender biased, is actually right. There is a difference, and a difference is a huge difference between performance level of male and female. This is, we were probably just speculating, we were thinking that may be the case, but now we have an evidence. We're not just being gender biased, we have an evidence that there is a significant difference in performance level of male and female. So here, what will be my conclusion? That we have enough statistical evidence to reject null and accept alternate. And now let's look at who is better and who's worse. That's how we would. So if we look at this particular box, this tells me females has 80 values, data points. Females have 101 data points in the sheet. The average of female is 17.24, and the average of male is 19.75. Now, the question is, how do we read and interpret this particular values? Is A, can I see a difference between female average and male average? Yes, I do see an difference. Is this difference a large difference between male and female? That question needs to be asked. Is it a large, like statistically significantly large differences? Can I say they are performing at absolutely two different levels? Uh, that question needs to be answered. Number one. Number two, keep this in mind. This is just a sample. You picked up a small sample where female has 80 valid data points, male has 101 data points. What if
Mr.
the,
Shafi,
yes, yes.
our colleague, Mr. Sanjay, he
Hmm.
tried to join the meeting, but he is just getting a message like,
Oh, okay. Okay, I think he should be able to get in now.
so he is just getting a host will be let you know, or like that message
Okay,
is
I think just I think okay. I think he should be able to join now.
shall I tell him to
Yeah, yeah.
join
Just
now?
he should be in. He should be in now. I think.
Yeah, okay. Yeah, he joined. Yeah.
Okay. Okay. Perfect. So,
Yeah. Welcome, Sanjay ji.
hello. Uh, is Mr. Sanjay there? I think he's okay. I think he should be fine now. Mr. Sanjay. Hello.
Hello, good morning.
Good morning. Good morning. Again, we just started pretty much like we won't be long, so we'll be able to catch up whatever we
Sure.
discussed because we'll be performing another example. Just started with it, so yes, we'll just continue with the same. So the basically, whenever we perform a test, the few questions that I want to ask any point in time, the questions I'll rather write it here first. Uh, that's like just to understand, like this is not what you need to ask any question. These are the answers what we look for, basic questions which can come to our mind. uh, is the difference what we see is huge and real differences? That's the first question I would like to understand and interpret. Second, because these are just samples, I have picked up, say, 80 samples and I picked up 101 samples. What if I increase more samples of female? Will the average change? Definitely, yes. If I reduce the samples of male, will the average change? Definitely, the average of male will also change. What if I increase more samples in every case? What if I reduce sample? Bottom line, what if I change the sample and pick up a new sample from the process? Will there be difference in the averages? Absolutely, there will be different averages. The question is, if we increase, reduce, or change the samples, or change the samples, will we see the same differences? Again, the question, that's what we want to understand and interpret. Do I see this difference? Yes. Is this a large difference that we can say that females and males are performing at absolutely different level? They're statistically different. That question. Second, what if I increase the sample? What if I reduce the sample? What if I change the sample altogether, pick up a new sample? Will you still see the differences? Females are doing a better job in this because time related data, lesser the better. So females are performing, taking lesser time, male is taking more time. Females are doing great as for this. But is this great definition? I would say, is this a large difference? The answer to all those questions is this p-value. Yes. The first question, do you looking at the p-value? Yes, I have a statistical confirmation that the difference you are seeing, these are real differences and are large differences. These are statistically significant differences. That's the answer to the first question. What if I change the sample? What if I increase sample, reduce sample, pick up a new sample? Will you still see the difference? Yes. These differences are real, and you will be able to see this difference in the population from which you have picked up this. So whatever process you picked up this data from, for that process, you can definitely say that females are doing a far better job than male. Why? That's a separate topic, but yes, we know the root cause. Males are not doing fine, females are doing fine. This is respective to that process. That's how we interpret it. I'll just do another just to make sure that we get it correct. Let's say for two groups where we perform a two sample t-test. So two groups, let's find out another data, another X, which has two groups, like hardware issue, network issue. Like let me go back to this two sample t-test, stats, basic stats, two sample t. I'm comparing ticket. This is my ticket closure time, which is my Y, and I have my X, which is uh, ticket type. I want to check whether hardware issues or network issues, are they impacting the business problem? Looking at p-value, I know this is a significant root cause. This is alternative. When we know p-value is less than 0.05, it's a root cause, validated root cause. We have a statistical evidence. When p-value is less than 0.05, it is a root cause. It is definitely impacting, and there is a huge difference. Let's look at the data. Hardware issues 20.36 as an average. Network issues are taking about 16.38. So network issues are taking far lesser time as compared to hardware issues. We have a statistical evidence which confirms the differences are real and statistically significant differences. And yes, that's a root cause. The type of ticket is definitely a root cause. Let's quickly have a look at another X, and then we can move on to the other type, which is, say, I have got shift. And we have two shifts, morning shift and evening shift, I guess. So we have morning shift, night shift. We have two types of shifts, 91 samples for morning, 90 samples for night. They have a difference, but slight differences. And looking at p-value, that's null. 0.922, that's more than 0.05. We do not have enough evidence to reject null. This is still, so null says both are performing at same level. There's no differences. Yes, we do not have enough evidence to claim that morning is better or night is bad, whatever you want to prove. Null will stays true. I hope two sample t, that's okay with everyone now. Two sample t test. Is this okay? Would request you to please confirm.
Uh,
So
Sir, just to recap,
mhm.
two sample t-test is only used if you have more than two groups, or two or more than two groups.
No,
And
no,
if
just two
it's
groups. Just two
just
groups.
just two, okay, if it's
Yes.
two groups and only if it's categorical.
Yeah, yeah.
Okay, thank you.
So comparing two groups and it's categorical, you will use a two sample t-test. And while you did this test, graphically, how would you show it? You'll use the box plot for this. So graphical test will be box plot. We all know how to use a box plot by now. Just to kind of do it to you. So here is the y, this is your x, say ticket type, put down your target, say whatever target you have management has given. So we've done this box plot before, but say still I want to put this target test 20. And so when I do the statistical test, I'll use this graphical test also to showcase there is a difference, a huge difference, and how this graph will be supported. This graph will be supported by your test, the two sample t test. So this graph, this test and the graph will go hand in hand. Let me do one more just to kind of get a clarity here. Uh, Say let's kind of scroll down a little here and see what are two groups, more categories of two groups. Say process complexity. So process complexity, it's a categorical data, yes, because this is not numerical, simple as that. If it's not numerical, it's categorical. Here, I have only two groups, tier one and tier two. So level one, level two, process complexity. So somebody probably wanted to say that level one is more important, more difficult. It may be taking more time. Tier two people probably were saying, no, ours is more difficult. Let's see whether complexity of the process, is that a root cause? Let's see. Stats, basic stats, two sample t. So when you're comparing the average of two groups here, which is process complexity, level one and level two, let's see. Probably we wanted to claim something. Looking at p-value, no ways. This is null. So you can see a difference. This is level two is taking 19.05 and level one is taking 18.10. Is there a difference? Yes, I can see a difference. Is this a large difference? Unfortunately, I can't say that. Why? Because the p-value doesn't support. This could be matter of chance. This is matter of chance because we have samples differences. What if I increase the sample? What if I reduce the sample? Will the differences still be visible? No. First question, are these differences large enough? Practically not. The p-value doesn't support that. So all those questions, the answer to all those questions will be answered by your p-value. So yes, when we look at p-value, you get an answer. Whether it's statistically different or not, no, it doesn't support that. So for us, whether it's a level one process complexity or level two process complexity, we are performing at the same level. Let's have a look at another example. Say we have got location, we have got two locations, Mumbai and Bangalore. We would like to compare where Bangalore wise performance is better than Mumbai or Mumbai is better than Bangalore. We're comparing the average of two locations. Let's find it out. So location wise, we'd like to check it out. uh, P-value doesn't support, so well, even the sample differences are not huge, but I don't want to look at sample differences here and take a decision because this is just a sample. What if I take more samples? It will vary. So bottom line, with whatever data we have collected, we do not have enough statistical evidence which can support your claim. So that's how we go about doing two sample t. And when it comes to the test along with it, go to box plot, pick with groups, and your this will be say location. We go to scale, we go to reference line, we put down the target of 20 here, and that's it. Pretty much that will take care of this. Is and more only looks like same. So both performing at same level. Null hypothesis, we don't have enough evidence to prove that this is the root cause. I hope this is good now. Everyone is clear with two sample t.
Yes, sir.
Okay.
So basically, what we're doing is we're checking if the box plot says if there are differences, and if they are, we support it with a two sample t-test.
Yeah, but ideally I would do graphical test. And see, graphical test may not give you a very, very clear picture, but that's a supporting. Here the statistical test will come first, and box plot will become as a supporting graphical illustration. That's how it is.
Thank
Primary
you.
will be your statistical test. Secondary will be your box plot to support it further.
Okay. Thank you.
Let's have a look at the 2 plus when we have more than two groups. How do we analyze that? Have a look at this this data. What is my 2 plus group here? When we are comparing, say, ticket handler. We've got four ticket handlers. I'm comparing the averages. Null says everyone is same. Jaya, Nitin, Ravi, Vandana, their performance average is same. Alternate says no. Somebody is really different from others. Let's see. So I go to start. I go to Anova. I go to one way ANOVA. Response will contain my Y, factor will contain my X. I click on response, select my Y, ticket closure time, that's your business problem. Factor is your X, which is ticket handler. Now, in ANOVA, we have an extra bit of element also. We add it because it makes it even more clear. So we click on comparison, and here is an option of Tuki. Tuki, we just select this Tuki, and we'll see it's a pretty good illustration of clarity, like gets clarity to the test. Click OK. That's it. We're done. Have a look at this test results. Null hypothesis says all means are equal. Everyone is equal. Alternate says no, not all of them are equal. Somebody is different. Factors, there are four levels, and there are four groups. We're comparing Jaya, Nitin, Ravi, and Vandana, four different groups. And that's when we're doing it. Now have a look at the analysis of variance with ticket handler, p-value. What does it say? Is it a root cause? Uh, is there a significant difference? Is there a significant difference? It is null or alternative?
This is alternative.
Absolutely, yes. It's less than 0.05. When your p-value is less than 0.05, you got your root cause. That's a statistically proven root cause. Yes, we have ticket handler as a root cause, validated root cause, no longer my judgment. Yes, it's a root cause. It definitely, people are performing at absolutely different level. Let's have a look at this. We'll give you clarity of thought. Jaya has 22 samples in this data. She has an average of 19.9. That's an average, but she ranges between 17.7 and goes until 20.6 with an average of 19. That's her range of ticket closure time. Nitin has about 56 samples with an average of 20.6, ranges between 19.7 till 21.5, and has an average of 20. Ravi has like 18.6, but look at Vandana, absolutely league apart. 58 samples, 16.5 as an average, ranges between 15.5 till 17.4. She ends at 17.4. These guys don't even start at 17.4. That's why we are getting an alternate. And just keep this in mind. Even if we remove Vandana from the data, still you will get alternate. Why? Because look at Ravi, he ends at 19.6, and this gentleman starts at 19.7. They are performing at absolutely different level. The differences you see between them, they are huge differences. They are not, and the reason why we clicked on Tuki is just because it helps you better. Have a look at this. It says means that do not share a letter are significantly different. So any data is given a alphabet, and if groups who do not have a common letter, that means they are different from each other. Nitin was given an alphabet of A, so Nitin's data was given as alphabet of A. Jaya, she has some features of A, and she had some features which were not resembling to A, was grouped as B. Ravi has all those features which are same as whatever the B factor. So Jaya has both the features of A and B of Nitin's data and Ravi's data. Jaya has combination of both of them. But Nitin and Ravi, they have nothing in common. They're absolutely different. But if you look at Vandana, she's league apart. She's different from everyone else. Nowhere where she's kind of interacting with anyone. That's how it gets you clarity that Vandana is a league apart, absolutely different, and time related data, lesser the better. So Vandana is phenomenal when it comes to the ticket closure time. And the worst one probably is when I look at this gentleman, Nitin is kind of really, really bad. And to get this additional clarity, that's the statistical test. I go and do a box plot along with it. So with groups, I go and get my box plot done. which is ticket handler, scale 20 minutes, same, and let's click OK. So this is where I see Vandana is a significant role model. For Nitin is the worst, Vandana is best. That's how we get, because anything less than 20 is good. Anything more than 20 is bad. I hope we're clear with this.
Yes, sir.
Okay. Let's have a look at another X and move on with this. Let's compare, say, qualification. We've got graduates and postgraduates, undergraduates, more than two groups. I'm comparing the performance level. So I have a null definition which says average of graduates, average of postgraduates, average of undergraduates. Their average ticket closure time is same. Alternate says no. Somebody is different. Let's see. Starts Anova one way. So ticket closure time is my Y. My X is my uh, qualification. Storage, sorry, comparison. I select two key, which is already selected because I did the previous test. Okay. Means are equal, not they are not equal. Three groups, which is 2 plus. This is why we're doing ANOVA. This is null. Unless it is less than 0.05, we don't have a root cause. This is more. So user qualification doesn't play any role. And let's scroll down to 2 key. See, everyone is put into one group. Same. They're all same. If we would have seen a different alphabet, let's have a look at some other test. For some other x's, x, let's say manager-wise performances. We want to compare the performance of various managers. Let's see. We've got 5 managers: Manish, Pooja, Reena, Rohit, and Soren. Still null. They're same. We do not have enough evidence to claim who is better, who's less. They are like almost performing at same level. See, look at this Tuki. Everything grouped under one alphabet. If we look at similar another X, say with trainer, is it null or alternate? Is it,
This is null.
yeah, null or alternate? Again, just have a look at it. 0.035. Is it null or is it alternative? Anyone wants to pitch in? 0.035.
This is alternate. This is less.
Absolutely. Yes, yes, absolutely. And look at this. Sam and Rajesh, they have been given. So when you get null, everything will be clubbed into one group. When you see a different letter, simply you mean that there is an alternate. A and B, Sam and Rajesh, they are absolutely different. Rajesh is taking like has got low average, and Sam has got a huge average, and the differences are huge and statistically different. This is why we're getting an alternate. A and B, they're not in touch with each other. In case when we're talking about this ANOVA, ANOVA can be done when you have 2 plus group, but we talked about this, the data is non-random. Then you will be doing a this Kruskal-Wallis test if your data is non-random. If your data is non-random, then you have to choose the Kruskal-Wallis. Process systems, wherever you were supposed to do ANOVA, instead of ANOVA, you will be doing a Kruskal-Wallis test. Now, where do you find the Kruskal-Wallis test? You'll find it in stats, non-parametric. And here in this list, you'll see Kruskal-Wallis. If your data is non-random, you will be using a Kruskal-Wallis. So why is your ticket closure time? In case our data is random, but just we should know where is it. And say ticket handler for 2 plus group. So we want to compare the medians. So Kruskal-Wallis compares the medians, not the averages. So it compares the median. Null says all medians are equal. Alternate says no, at least one median is different. P-value confirms that yes, there is a significant difference. And we're looking at the medians of their Vandana is the best, Nitin is worst. That's how it further validates. This compares the medians, not the averages. All the tests that we've done, we were comparing the averages. Why we when we would do this test of Kruskal-Wallis, we will do it only when your Y is non-random. Instead of ANOVA, you'll use Kruskal-Wallis because every other test was comparing the averages. Here we're comparing the medians. Why? Because my data is non-random. Simply, let's say we have another test. Let's pick up another 2 plus group. Say we're comparing the trainers. We got alternate there. Here it is not. Have a look at this. This is 0.06. The median, it's not alternate, it's a null. So by comparison, but if you're using median as a criteria, this is not the one. But yeah, we will only use this test when your data is non-random. I hope we're clear with this, everyone.
Yes, sir. So basically, the Kruskal wall is so that we would know, we will have to test for normality first, right?
Yes, yes. No,
Okay.
normality, run chart, randomness also. See, you first do your normality test to know the normality or non-normal. Then you do a randomness to know whether data is random or not, which will help you understand whether in this data you're going to be using a Anova or you'll be using a Kruskal-Wallis. Once you have that understanding, then you can start with the testing. Like it barely takes any like 5-10 minutes. You've been done with all the statistical tests. Is this 2 and 2 plus clear to everyone?
Yes, sir. Can I
Yeah.
request for you to repeat again the process? Just the
The
process. I
the Kruskal
mean,
Wallis, or okay,
no, no,
how do we
no.
start? Yeah.
Just the overview.
Okay, sure, absolutely. So
Just the
whenever
overview.
we have the data, like any data, this data is collected, and I want to start with my testing, the hypothesis testing. So I will always start with my normality test. First thing, I
Okay.
always start with your normality test. That's what we
Okay.
mentioned it as the beginning. First, perform your normality test. Get to know whether data is normal or non-normal. Looking at
Mhm.
p-value, so you get to know your data is normal, your data is non-normal. You move on to perform randomness tests, which is run chart. So when you do perform run chart, you want to check whether your business problem is randomly distributed or not. And for that, we do a run chart. We go to start, quality tools, run chart. Again, you get p-values for every, so your subgroup size is one because single column is there, and you perform your run chart. You get four p-values. If any p-value is less than 0.05, then it's non-random. This one, all of them are more than 0.05. This data is random. So because this data is random, all the p-values, p-value for clustering, p-value for mixture, p-value for trend, p-value for oscillation, all these p-values are more than 0.05. Hence, I can use ANOVA. But if any p-value would have been less than 0.05, instead of ANOVA, I would be choosing Kruskal-Wallis. That's how this is a preliminary test. Now, because I know the data is normal, data is random, for all the two groups, I will do a two sample t. So wherever there are two groups like gender, I had ticket type, I had say shift. Wherever there were two groups, I will do a two sample t test. I'm comparing two groups. When there are more than two groups, like background, I have got qualification, three groups here, manager, more than two groups. Whenever there are more than two groups, I will be using ANOVA. But if my Y would have been non-random, then I would use Kruskal-Wallis instead of ANOVA.
Yes. Okay.
Is
Okay.
that okay?
Yes. Yes. Thank you. Thank
Perfect,
you.
perfect.
It's more
Uh,
clearer now.
yeah. Now moving on to correlation. So before we do correlation test, let me give you like some, because it'll give you some bit of extra information that we should be clear about. When we perform a correlation test, it gives you p-value, which we generally get with every test. P-value tells you whether there is a relation or not. That's what it tells you. But it also gives you an R value. Correlation test will give you an R value, which is also known as Pearson's correlation coefficient. Now, what this Pearson correlation coefficient, this small r, uh, what does it mean? It tells you what kind of relationship is there between x and y, and how big is that relationship. So first thing, the nature of relationship and the magnitude of relationship. So when you look at r value, it will range between -1 and +1. That's the r value will range between this only. So some examples of it so that we know what is how to interpret the R value. This R value can range, if it ranges between 0 and 0.3, it will mean that there's negligible or no relation between X and Y. If the R value is between 0.31 to 0.75, you'll see there is a weak or moderate relationship impact between X and Y. And If it is more than 0.75, then you'll say there is a strong relationship between X and Y. That means a big root cause, very, very big one. Like the impact of it will be much bigger on Y. Other than this, these are the values which will tell you the magnitude. But it will also have a positive or negative. Like positive one will be just like a positive number. Negative means will have a negative sign in front of it. Positive means there is a positive relationship between X and Y. Negative means there is a negative relationship between X and Y. Some examples so that we know. Say when you perform a test and say for a random example, you get a R value of 0.21. It's a positive one, yes. It falls into this zone 0 to 0.3, which means there's negligible impact. So when you get an R value of 0.21, that means there's a negligible impact. And generally when you get this, you always get p value for which is null. You'll never see this is R value is strong and you're getting a no, that will not be the case. So here when you get a R value, you'll always see this is p value will be also null. This is how it will generally be. R value, say if it falls as 0.56, it falls into this quadrant, which says there's a weak relationship and it's a positive one. There's no negative sign. So I'll say there's a weak positive relationship between X and Y. And for this, you will get an alternate always. Weak positive relationship. Positive because there's no negative sign and falls into this zone, which is weak positive relationship. Say you get an R value, which is 0.89. Well, I'll say that's a strong positive relationship because it's a positive thing and strong because it's more than 0.75. Similarly, we can have these values like minus 0.25. It falls into this zone, negligible. So practically I won't say negative because there's almost no relation. So I won't say negative relation, negligible. Minus 0.65. It falls into this section. I'll say weak negative relationship because it has a negative sign. So X and Y are negatively related and the impact is a weak one. Strong negative relationship, say 0.91, falls into this quadrant, has a negative sign. What does positive negative means? In a positive relationship, if X increases, it also increases the Y. Like for example, if the temperature increases, it increases the sales of ice cream. Yes, X is the temperature, and what is it increasing? The sales of ice cream. So when X increases, the temperature increases, people tend to buy more of ice creams and all that. Like you have speed of a car and the number of accidents. As the speed increases, the people drive faster, you will see more accidents happening at a faster speed. Like the number of hours we study versus the kind of marks we get. So when X increases, your Y tends to increase. That's kind of a X and Y relationship, which is positive. When your X increases and Y decreases, practically that's a negative relationship. For example, when you buy a new car, it gives you high mileage. But as the car gets older, the mileage reduces. When X increases, which is age of the car, if it increases, the mileage reduces. Similarly, age of the car and price of the car. The second-hand car companies, the market, and they kind of do all that stuff, correlation stuff, and they have this pricing, this determinant from these factors. But practically, that's a negative. When X increases, Y reduces. So when we do a correlation test, we will get both p values, we'll get R value, and we'll be able to see a scatter plot for that. Let's just have a look at it. Let me just quickly go back to this folder. Containing material, you have got in the analyze phase, you have hypothesis test, you have a correlation scatter plot file. Just check this out. So I'll just show you some examples so that we understand sales and temperatures simply. Say, let's go back here. Okay. Sales is my Y. I want to check whether this X, which is numerical, is this X impacting my Y, which is Y. So when my X is impacting my Y or not, X is temperature, Y is sales. So I go to stat, basic statistics, and here we'll go down to correlation. Correlation, we click on correlation. There's no two separate boxes here for X and Y separate. No, correlation gives you only one box, but ideal way is to put X first and then the Y. So temperature will go first, which is my X. I want to see impact of temperature on sales. So sales will go second. Click on results. Click on pairwise correlation table, and then click OK, and then OK. That's where your That's your scatter plot. We'll understand that, but let's scroll down and have a look at the p-value. P-value confirms it's an alternate. There is an impact. There's a relationship. P-value confirms there is a significant statistical relationship, but how big is that relationship will be explained by the Pearson correlation R value. This is the R value. R value, Pearson correlation coefficient, which is here also. What kind of relationship I would say? This is a strong positive relationship because this falls into the more than 0.75 range, which is what we discuss. If it is more than 0.75, yes, and it's a positive one. So strong positive relationship. That means if X increases, my Y will also increase. Have a look at this scatter plot. I'll double click on this graph. Let come up. It says add items, and we always prefer a regression fit line. It shows you the direction that's going diagonally up. That means if my X was low, my Y was low. My X increased, my Y increased. My X increased, my Y increased. Gradually, my X increases, my Y increases. As my X is increases, my Y increases. So when my X is low, my Y is low. So this is directly proportional sort of thing. So practically, the relationship here is a strong positive. If my temperature increases, my sales increases. My temperature is low, my sales is low. That's how a positive correlation would look like. A line going diagonally up means there's a strong positive relationship. Strong positive relationship as the line goes diagonally up. If I want to show you some variants of this, let me show you this another example which is in the sheet. We have a negative relationship, the same age of the car and mileage of the car. Let's have a look at this. Same process, stats, basic stats. I do a correlation. I want to check whether age of the car will impact the mileage. X first, Y second. Results, it's already selected because I did it last time. Click OK. We'll look at the chart later, but let's have a look at p-value. P-value confirms, yes, there is a relation. Yes, but what kind of relationship? Strong negative relationship. If my X increases, it reduces my Y significantly. There's a strong negative relationship. It comes with a negative sign. Let's have a look at this chart. Click on this graph, add item, look at the line. A line going diagonally down shows you a negative relationship and strong negative. A strong positive will go diagonally up, a strong negative will go diagonally down. My car was new, it was giving me high mileage. The car got older, it reduced my mileage. Car got older, lesser mileage. Car got older. So as the X increases, my Y reduces. The X is low, Y is high. X increase, Y is low. It's a inversely proportional relationship. It's a negative relationship. You can get any kind of relationship. And we'll have a look at this third one, no relation kind of thing. So you can get everything like whatever, depending on the data, what you get. You can see something like this also, different variants of your outcome correlation. So I want to check whether number of hours I work, does that determine my salary? Okay, let's see. Pairwise correlation, we'll click OK. Come back here. Let's look at p-value. P-value confirms no, it's null. Look at this, it falls into the no relationship zone, like sort of thing. And 0 to 0.3, it's no relationship zone. R value also shows up here also. Just scroll up, have a look at this. For this particular data, for this particular organization, doesn't seem to have a relation. The line is almost like a flat line. What it tells you, somebody has an let's see, somebody has worked about 63 hours, earns about 23,523. Somebody who works like 90 hours earns about 49,000. Somebody who works 169 hours is making just 21,000. Doesn't seem to be a relationship between hours work. Like, see, look at this, and this everyone. Somebody is working with 221 hours is making 30,000. Somebody's working like somewhat like it doesn't have a relationship here. 223 hours is making 47,000. It disproportionates sort of thing. So practically there's no evidence like it's going to be like whether salary is driving, the hours are driving your salary. No, practically you need to understand like different people are of different job role. Probably that's what we have. But more like when you look at data, you can get the like data which can have an outcome like positive relationship, negative relationship, or no relationship also. So like null and alternate. Generally, when you get a positive relationship or negative relationship, you get an alternate. When you get a weak one, like this negligible one, you always get a null. Like in this case, this is how we perform all this. So all these x's that we have here in this spreadsheet that we had two numerical x's only: customer satisfaction score. Rest was categorical. We had number of follow-ups. I want to check whether customer satisfaction score is that impacting or not. Let's have a look at this. Let's go back to the sheet. Stats, basic statistics, and correlation. I want to check whether customer satisfaction score, which is my x, is that impacting my ticket closure time. Let's have a look at it. The image shows practically no, it's null. Looking at this image itself, uh, it's null, no relationship. And look at this line, it'll be a flat line. Nothing following it. No, it's not following a flat pattern. The line tells you all, because at the same level of customer satisfaction score at time, like I can see different sort of. So somebody who's getting a CSAT score of 12 is taking time of 13 minutes also, and for different CSAT score it's for 23 minutes also, same. So customer satisfaction score is not driving your time, so it's all scattered everywhere. So that's how we test. Is it okay with everyone?
Yes, sir. We get the test from against stats and from the MINITAB. Can you show me again one last
Which
time?
one? This one?
Yeah, yeah. Stat.
Stats, basic statistics, and correlation.
Okay, thank you.
Now, post this, once we have performed our test, we would be it a two sample t-test, be it Anova or Crystal Wallis, depending on your randomness part, and for that matter, correlation, you would know your real root cause, which brings an end to the analyze phase. You would jump into the improve phase. But the most important uh, part here that we need to understand, like, so once improvement is the phase where we will start getting into action. We'll start performing a lot of test like action in terms of improving it. Right now we have validated the root causes. We know what's my real problem. It's not my speculation. We have got statistical evidence which confirms what is good, what is bad. So I start with my improve phase. But before I hand over, see, our role will become a secondary role in this stage. Why? Because we are not process experts. We are dealing with the area which we know best, which is statistical analysis, quality management, project management part of it. But core technical knowledge we may not have for everything, depending on which area, which department we're working in. So this the reason why you were required, because you bring these additional tools to on the table. So you bring quality management, you bring in statistical controls, you bring in project management tools and techniques to simplify and streamline the things. But at this stage, because you have already identified the root causes, the process experts, the subject experts, technical experts will step in, and that's why you will probably most likely hand over most of the material, like data, because if you there are every organization has process experts. If you tell them the problem, they'll be able to solve the solution, solve the problem for you. Because the only reason why we did this Six Sigma star stuff is to understand what's causing it, because we had no crystal clear problem. Now we know the problem. We can help the process experts with some bit of information. So we first want to understand before we hand over this process data to be worked upon to the process experts. We want to give some bit of more idea, some bit of more information for them to help. Now, we have identified the root causes. We want to understand not all root causes will be equally important. Some root causes will be very important. Some root causes will be lesser important. They are root causes, yes, but not everything is equal. So you want to understand which one is more important, which one is less important. For that, we will be doing a regression test. So regression test, there are two types of regression we'll be talking about. One is a simple regression, second is a multiple regression. In a simple regression, we test one x with a y at a time, the way we have been doing, one x with one y. We'll get a p-value for that test. We'll get an r square. We'll understand what is r square, and we'll get an equation, linear equation. We'll learn it, like we'll understand it in the multiple regression. We'll skip it here because it gets repeated here. Then we'll be doing a multiple regression also. Here we test multiple x's with y at the same time. We get p values for all those x's. Instead of r square, we read r square adjusted and we get a linear equation also. So we will first start with simple regression and then we'll move on to multiple regression. This is just to keep this in mind to understand which root cause is more important, which is less important. So let's have a quick look at the, like there's a improved phase data, you have data files, okay, regression. So I copy paste this data on MINITAB and let me explain how this the regression part works. So this is say about some business, some HR firm who wants to streamline their hiring process, and they want to understand like some sort of come up with some sort of mathematical model which will help them understand what should be the right salary we should offer to a candidate. We just don't want to offer like salaries to different people on an ad hoc basis. Well, I feel that, and or you, I feel something, you feel something. So we want to take away that biasness or element of doubt. We're going to come up with some mathematical model, some statistical model to offer right salary. So, like we have this business problem, and we have said people argued that whether you're male or female, that will be also a criteria in deciding how much salary will you get. Well, I don't want to say that the management is gender biased, but we don't want to like contradict anyone because we'd like to see the results. So yeah, we included say gender as a root cause. This uh, somebody felt like no, how well do you do in your interview? That will definitely impact how much salary you get in the you offered. Some people believed now how experienced you are during the interview, um, at the time of interview, that will be a big deciding factor. So we included all those factors. Now we looked into HR files, we picked up hiring data, and these people were already hired by organization at some point in time. So we want to use historical data to predict the why for future. We're going to use the historical data to make some statistical analysis to help us for the future recruitments. So we got into the HR files. We picked up. We found that somebody was offered some salary like 88,000 or whatever. So we kind of was a female when she was hired. Uh, she scored. See, we've been probably doing some sort of testing on some psychometric test or some sort of assessment being done during interview. So she scored about 4.5 out of 10 when she was hired, and she had 11 years of experience, and she was offered 88,000 salary. Based on this, we're kind of filling in the data based on now these people may or may not be with us anymore, but we hired them at one point in time. We just try to go back to HR files and plug in some values there. Somebody was hired at 77.3, who was a male, uh, scored 7.8 during the assessment, and when the person was hired, he had 6 years of experience. So we kind of got this data. Now we want to use this for our analysis. So we'll start with simple regression to understand which X is more important, which X is less important. So how do we go about it? So we go to start, we go to regression, we go to regression, and we go to fit regression model. So start, regression, regression, fit regression model. We click on this. Now response is my Y, which is salary. Double click the salary, it comes here. So numerical X's will come here, categorical X's will come here. So you will test numerical X's, put the numerical X's in this box. So we have interview score in this data. We have got interview score as numerical X. So we're doing a simple regression, which will select one thing at a time. So it's interview score. We're going to check the impact of interview score on the decision of salary. Let's have a look at equation. We'll skip for now because we'll get repeated multiple. Let's look at interview score, p-value. That confirms there is a relationship. Yes, p-value confirms the same. This is alternate, and there is a relationship identified here. Perfect. Now let's look at r square. I'm just like r square is what I'm taking for now. So we get, if you go back to this one, we tested 1x with y, we got a p-value, we looked at r square, and the equation we're skipping. So r square, we kind of noted down 52.98%, 52.98% for interview score, and it's an alternate. We found that it was alternate because p-value was less than 0.05. That's the details from the first X, which is interview score. Let's change this to experience now. This is numerical x. Now that gives me this equation. We're skipping it again. Experience as alternate. There is a relationship, and r square is 83.26. We'll just put it 83.26, and it was an alternate. Let's go to gender. Now, gender is not a numerical x. So we'll delete this and we'll come here. Categorical predictors, categorical x's. We put in gender here. So gender comes in here. We test it. Now, equation we still skip. Let's look at p-value. That's null. 0.06. That's null. R square 10.06%. Let's have a look at this. Gender 10.06 and it's null. So this tells me basic information that I got, and this is what I wanted. What is this R square? We've been collecting this value. R square tells you the degree of, in technical language, that's what I will say. It tells you the degree of variability X explains in Y. What is the Y made up of? That this is the percentage of Y in like, so this is the deciding factor. In a nutshell, in layman language, I say how much of impact X makes on Y. The degree of impact X will make on Y is explained by R square. How big is the root cause? So as per this, experience seems to be the biggest factor which drives your salary. The decision of offering somebody's X salary or Y salary will be much influenced by experience than by interview X, how well you do in your interview, and third by gender, if at all it has any impact of whatever is 10. How big is this 10.06? We'll understand it, but for now, that tells you the hierarchy, the impact factor by every X. That's what we wanted to know. Which X is more important, which X is less. My job at technically it gets done here, but still we want to further understand and more deep dive into all this stuff. So we'll do a multiple regression. So what do we do in multiple regression? We test multiple X's at the same time. So we got gender here, we put in interview score, we put in experience also. See, you may be having, if you have more than 5x's, do it in batches. You don't kind of test with a lot of x's at the same time. So do it in batches of 5. That should be still fine. So you can, because it becomes too clumsy, data, it becomes difficult to read and interpret the data because sometimes the fun factor will cancel each other. That's how it can also happen. So avoid, it's prescribed, always recommended not to test more than 5 at a time. So let's click on it and let's have a look at it. This equation will come later. Let's have a look at this. Interview score, alternate. There is a relationship. Yes. Experience. There is a relationship. Gender. No, that's null. No relationship. Have a look at R square adjusted. Like we're not looking at R square. We look at R square adjusted. That's what we talked about. R square adjusted, which we have maintained here is 88.84. Now, what is this 88.84? What does it mean? Adjusted part. Now, keep this in mind. When this interview is happening, and we know interview score is putting 52.98% impact on the decision. Experience is putting 83.26% impact on the decision. And if gender at all is impacting whatever this value, howsoever impactful is this 10.06, it's also emphasizing some bit of impact on the decision of salary also. So these are the individual impacts. But when the decision is being taken, all these forces are acting on each other at the same time. Interview score is also impacting the decision making, experience is also impacting the decision making, and gender is also, if at all, whatever it is, but it is impacting all these forces acting together. What is my overall impact? Ultimately, given all these factors together, this is what it explains. What's my overall impact? The decision of salary, the final salary that I'll offer to the candidate, is explained by these three factors. 88.84% of the decision is coming from these three factors, which is 88.84. Now we'd like to clean this model to understand how good is the model. So we'll go back and want to understand it further. So what I want to do is I want to understand how big is this experience. So let me just remove this experience and see, does it deteriorate the quality of the model? I will understand what will be the loss in the overall quality, the impact factor. If I remove experience from this, I am down to 55.74%. It's a big cause, big root cause I have removed. So when I removed experience, I dropped to 55.74. So I lost about 33.10%, which is a very, very big root cause. Experience, we know, was the biggest of them. So this biggest impact, so I know how big is this particular, the contribution in the overall decisioning was like you lost a big chunk of it. So it is a crucial one. So we put it back and we want to see how big is this interview score and this overall collective model. So you put in, remove the interview score and put the experience back in. We want to check the loss of experience, the interview score in this entire model. That's when we go back here, 82.43. Well, you dropped interview score, you're down to 82.43 from this overall model, uh, which is lost about 6.41%. I'm not saying it's negligible, it's a big percent. The 6.41% drop is also significant, but not that big. Like it's a huge one. So yes, definitely this is a very, very big root cause. Experience followed by interview score. So but these two were alternate. Let's put them back and just remove the gender. Let me put back the interview score also, remove the gender. Let's see what is the loss of interviews, the gender in this model. If I remove gender from the model, I am down to 88.78. I've got clean model now. Both are alternate. This is 88.78, 88.7. What I lose is 0.06%. This is the overall impact which it was making in the entire model, 0.06%, if at all it has any relevance. This is the only decision the overall influence it was kind of putting in, which is nothing, and that's why it's null. So now we have got a clean model, which tells me the overall quality of the model is 88.878%, which explains the decision making. It tells me both these factors are alternate. Now we look at the equation we have been skipping for now. Equation is generated, which helps me predict my y, and that's coming from my own organization data. Let's have a look at what it says. Salary is equal to 53.22 plus 1.754, and just copy this information here. Now let's understand how does it work. This is based on the linear equation model, which is y is equal to c plus mx. And what does it mean? Y is your business problem, which is salary in this case. C is, in statistical language, it's called as intercept. And in a basic layman language, C is minimum value of y, the base value of y, which will always be there. It is when your value of x's are 0 in the equation, what will be the value of y? And we'll look at some basic equation, we'll be able to solve it. Keep this in mind. This is the value. When value of x is 0, C is the value of y. This is the minimum value, base value of y. M is uh, M is the slope, which is in layman language, it's a multiplier of x. So we'll just try to figure out how to and interpret this equation. 53.22 is the constant value. Constant value comes here, plus 1.754 experience. This is what is 1.754 experience. So 1.754 multiplied by the value of experience. So we keep experience as 0 here. Okay, this is blank. So 1.754 multiplied by experience, simply 2.105 multiplied by the interview score. And see, all of them are getting multiplied. 1.75, 153.22 is here. Whatever is the product of 1.754 gets added. So 1.754, whatever is the multiplication factor, this will be added to 53.22. Similarly, plus 2.105. So whatever is the product will be added to this. So all these three will decide the salary. Now, somebody comes for a job interview and scores 0 out of 10 and scores has 0 experience, absolutely out of college, just out of college, no experience. When your value of x is 0, experience multiplied by this interview score multiplied by 0, impact 0 impact. This is the base value. When the value of x is 0, this is 0. When there is no excess, what will be the bare minimum salary that you'll be offering? That's what C explains, 53.22. Now there's somebody else who joins in and comes in, has a 4.5 years of experience and scores say 6.7 in the interview, offer the salary. Well, somebody comes in with a 9 years of experience, oops, my bad, 9 years of experience and say scores 2 out of, you have a calculator ready. That's how a lot of companies have created different kind of calculators which helps them in decision making for various metrics. So keep this in mind. This calculator uh, is effective up to what level? This is effective up to level of 88.78, because when you remove the gender, this is the final one which we got, 88.78. So the decision making, it can be explained about 88.78. So you're very close to the overall decision making. So yeah, you when you kind of going with this r squared adjusted based on this particular formula, this is very very good. Any r square which is above 70% is considered to be a very good predictor of the model. Higher the r square adjusted, better is the model. So, but looking at this is pretty good, handsome black model, and we can use this. And when we look at this overall prediction, it helps me. You got to keep this in mind. You can only use this model till the time your values are in the range of, like, let me go back to this one. Yeah, what is the minimum and the maximum here? Minimum of experience, say minimum 2 years and maximum. So this model will give you correct information only if the area age, so the experience falls between 21 years. Uh, what if you want to test this, that somebody with a 25 years of work experience, no, sorry, that will not be true. It will not work fine for that. So anything up to 21 years, it is going to cover up for that. Why? Because this model was created using data which has. So what if you want to add? Yes, you can add data and then create a new model from that. But because it was never constructed in for that range, it will not be the right thing to do. So yes, going forward, you continue adding more data, do a new regression, create a new equation that will help you to construct and understand how the regression works. But bottom line, it helps you come up with a mathematical model to predict your y.
Mr. Prakash,
Yeah.
sorry, I my internet had a little problem. Can you give me a little bit of example again how you came up with the experience and interview score mathematical model?
Yeah, so when you tested this all the multiple x's at the same time, this is what you get. Salary is equal to 53.22. This is on the top. This is on the top. When you test multiple regression, I don't know where did you missed out? Like, is it the what did you check this one, like interviews when we did multiple regression?
Yeah, that I was able to understand.
Yeah, so this
So
equation is when we have only the alternate ones which have root causes. Experience is
yes,
the root cause. This is also root cause. We look at the
yes,
overall model, which is 88.78%, which is very good. And then we look at the equation. This is my cleaned equation, because all the, so now I start interpreting this model, this equation on here. So salary, it says constant value. Salary constant is 53.22. That's your base salary that you will be offering any which ways, plus 1.754. So I said 1.754, whatever is the value of experience, and similarly 2.105, what is the value of interview score. So these, it is getting multiplied. 1.754 is the multiplier of experience, 2.105 is the multiplier of interview score. So somebody comes in with a job interview, say has a 5 years of experience, so this gets multiplied with 5 and gives you the component which needs to be added on to 53.22. Similarly, the person scores during job interview 7.5 during job interview. So 7.5 is multiplied is 2.105. So this will add the component from interview score perspective. So you come up with a salary which is like 53.22 plus 1.754 multiplied by experience value plus 2.105 multiplied by the interview score value. So that's how you get your overall salary predicted. So this is helpful till the time you're working within the range for which the data was used. In this case, say experience, we used the experience of like up to 21 years. So this model will give you correct information up to 21 years. Beyond that, if you have, say, if candidate comes in with 25 or 30 years of experience, it will be wrong to use this model. You should then add data in the model, come up with a new model and new equation which will help you predict using that model.
okay. So
Does that
you're
not?
telling me
Yeah.
if they got the maximum experience and the maximum uh, interview within that range, they
Yes,
should be
yes.
getting the highest possible salary.
Absolutely, yes, and very the accurate one, which should be predictive, which should not be influenced by someone's wills and fancies or preferences. It will be coming from the historical data, which we our own organization historical data to predict the future data.
One last question, sir.
Yeah, yeah,
So,
please.
what was the formula for getting the salary? Is it
So
the
it's coming from here. It's coming from the equation here. It is coming from the regression equation itself.
okay? Okay.
Salary is equal to 53.22 plus 1.754. Experience.
Oh, oh, I get it. Now you add whatever, multiply it by that,
Yeah,
and
yeah,
then you
yeah.
add 50. Okay. Okay. Thank you
Absolutely.
so much.
Thank you. So, okay, I guess it's 2:05 at my time. Like there will be somebody's like I think we as we've been taking. Is it okay to take the break for first break now? Because what I recall we have been taking the break. Uh,
Absolutely.
okay, so let's break for about 30 minutes. We will resume in another 30 minutes from now, whatever time zone we are in. Let's start in another 30 minutes from now. Okay.
Okay. Thank you.
Yes, Mitesh, you have a question? Hello? Yes, hello. Uh, we'll be starting in a minute.
I'm here.
Hi, Elizabeth. Yeah, I guess most of us are back from the break. Elizabeth is there. I guess Sanjay, you're also there. Okay,
Yeah,
perfect.
I'm here. I'm
Yeah,
here.
perfect, perfect. All right, so we'll resume. Basically, we before going on the break, we talked about the regression part, which is where we start the improve phase. We want to, it's the action phase where we actually start improving things. All we were doing until the improve phase, we were trying to speculate. We want to collect data, perform analysis. We have not done anything for improvement yet. So once we have done analyze, we know our root causes. We would further like to understand which root cause is more important, which root cause is less important, for which we do a regression test. We understand that part of it. Now, from there on, we will be leaving most of this stuff for the process experts, the technical expert who understand the process, who've been working on the process to fix that process because they have the core technical functional understanding of the process. Now, first thing first, we what we do is we always go with identifying the possible solutions. You will be discussing a lot of stuff with the subject matter experts. You look at your analyze phase test results, like say you compared male and female performance. You know, females were better, male were not. You compared trainers. One trainer was good, others were not. You had ticket handlers. One ticket handler was exceptionally good, others were bad. So you have a clear line of sight as to what is good and what's bad. Now it's all about deep diving into it to understand which why, if something is good, why, and if something is bad, still I want to know why. because if something is good, I would like to make it a practice. I would like to know why, so that I can make it a practice. Something was bad. If something is not right, then I would still want to find out why it's bad, and I would like to stop it. So because we have those idea of what's good and bad, pretty much we would be able to frame solutions. But you just never start with finding out solutions before you do a Gamba walk. Now, Gamba walk, I think like we discussed it initially, but just still want to make sure that it's barely we whenever we want to find out solutions, you really need to go to the place where the problem is happening. Gamba walk is a floor walk. Floor walk wherever the process is happening, the production is happening, people are working. Go and see it yourself. You can't sit in a boardroom and then start formulating solutions. No, you got to be at the real place to see the problem yourself, with your own eyes, and that's when you'll be in a better position to construct like devise a lot of strategies and solutions when you have seen it with your own eyes. You know how it works. You don't want to listen to someone's interpretation, or like this is how we work, this is what we should do. There should be some justification for that. So Gemba walk is a prerequisite whenever you're starting with any improvement strategies. You must do a Gemba walk. Go to the real place. Say, for example, we saw that male and females were doing a better job. Spend some time on the production floor, operations floor. Uh, See it yourself what females are doing, how they're different, and then observe probably male people also, like how what is that they're doing which they're not supposed to do. Probably they're chit chatting more, or probably they're not focused enough. Bottom line, you got to spend some time there. You didn't say, for example, my night shift was bad and morning shift is good. I need to know why. Well, probably in the morning shift, every higher management professionals are there. Uh, People from higher management, because they're there, people are more attentive and all that. In night shift, pretty much the higher management people will not be present. So people are casual, relaxed. Even the reporting managers are very casual about the way things work. And so I need to spend some time. I need to spend some time in the morning shift, spend some time in the night shift, see how somebody is doing the job. We have trainers, so spend some time in training of one person versus other person, take feedback. So you've got to be at the real place to get the solution. So once you've done your Gamba walk, come back and start with your root cause analysis. Most commonly, like the way we do go for root cause analysis, we go with a 5 why technique, or it's also known as a why technique. So what do we do in a 5 why technique? Practically, will have to, what it says that you have to, if you ask why 5 times, you will get down to the bottom of it. What's causing that problem? You have understood the root cause, yes, but what is causing that, it still needs to be uncovered. For that, we have to formulate solutions and all. So but you need to get down to the bottom of it as to why you're facing that problem. So let's take an example. Say I know my morning shift is good and night is bad. So when I spend some time, I see that, yeah, people in morning shift are very attentive, very focused, uh, whereas that's not the case in the night shift. Well, I know for sure the question, that's why is your night shift bad worse and why is your morning shift good? Well, when I spent some time, I saw that people are more attentive. Why people are more attentive in the morning shift and not in night shift? Why? Because there's a management presence. Well, that's why I know the problem is not with the shift. The problem is the factor that management presence is not there. People are more casual in the night shift and they're more attentive in the morning shift. Secondly, again, in the morning shift, people are like any which ways you're working regular shift hours, but in night shift, people are like you any which is working against the nature, like if you're working at night. So people feel more lethargic and all that stuff. So there's a need to ensure that people are attentive, people are like they're motivated, and you do some sort of activities to keep the like people, everyone like up to the like, so that they don't feel sleepy. But give some extra breaks, some refreshments, excessive lighting conditions, just to kind of pep up everything. So bottom line, I need to be there. When I ask why, well, I might see people are not motivated. Why people are not motivated? Because they aren't getting salaries. Why aren't they getting salaries on time? Because probably the management, like we have not been able to spend like share the details to the HR people on time or finance people on time. The problem is not that people are not motivated. It's linked with various factors. What is causing that problem? So when you do a why analysis, keep this in mind that you don't necessarily need to ask why 5 times, but it's in general, you can get your root cause within the first why also. You might take up to 5 whys, or you can take more than 5 whys also. It's not necessary that you have to always ask 5 times why to get down to the bottom. No, you can also get it in the first why. In general, maximum within 5 whys, you should get your root cause identified. So it's all about drilling down why it happened, why it happened, why it happened. So every till the time you get down to the bottom of it, okay, well, this is why it's happening. So it's a chain, it's a link. Everything is linked with another. What we see as a root cause is a superficial one, but that superficial root cause is further linked with various factors, and that's what we need to introspect. And people who are technical experts, process experts, who spend time in the process would be able to help you understand what's right and what's wrong, what things are happening, how people, like, what is the training methodology and all that stuff. Whatever may be the problem around that, we'll be able to formulate some solutions. Now, in a Six Sigma world, because you'll have a lot of access, a lot of possible solutions, we can construct, like, we can create a long list of possible solutions, but those solutions needs to be prioritized. You can't implement all the solutions at one time. So you need to prioritize the solution also. So what we use is X and Y relationship matrix for prioritizing the solutions. You may construct a lot of action plans, but you can't implement all of them at the same time. So this is how your X and Y relationship matrix looks like. Say we have a concern, a business problem, that the productivity is low. So that's my why. Say we got, just for an example, say we have got two root causes identified. This is where it says vital axis. One is trainer. So we say found that A trainer was best, and B, C, D, E, there are five trainers in total. Remaining four were bad. So we must have done ANOVA in the previous case. So we had five trainers, one was best. So we know this came as a root cause, which we identified from there. Then we have a shift, like morning shift was good and night is bad. So we've got two shifts only. Two sample T would have been done there. So we've got our root causes identified. That's the end of analyze phase. But now we sit down, and with the team, all the relevant people related to this process will be invited. So the process experts, subject matter experts, anyone who's related, probably somebody from quality, somebody from HR, somebody from training, or relevant stakeholders who have vested interest in the process will be a part of this particular activity, where you want to brainstorm for possible solutions. But keep this in mind, before you think about these possible solutions, you must have done a Gamba walk. You must have seen it from your eyes. It just can't be done like that. So yes, you sit down, brainstorm few, just some sample action plans. But in a real project, the list of action, all those action plans are listed here on the top here. And this list could be a very, very long list, but just for ease of understanding, we just kept it like three or four action plans per root cause. That's it. So trainer A was the best. So we wanted to kind of fix the root cause, which is trainer. Different people train differently, and because of which it's causing huge variability. One trainer, whosoever this trainer A trained, was doing phenomenal, and other people were bad. So what we felt like, train the trainer program can be introduced, where every trainer can go through a rigorous training also. So it's that, not you, like, once you become a trainer, you don't need further training. So you need to go through regular training yourself also. That will help them come up the learning curve. That was thought, that it's a good action plan. We must implement that, so that we can fix that, bridge the gap between the trainers capabilities. uh, then we thought of, like, a best practice sharing sessions to be conducted by the trainer A. He's my role model, he's the best trainer. uh, why not have trainer A share the best practices, how he or she manages to like, conduct or deliver such efficient trainings. So, like, why not hear it from the horse's mouth? And this is the best trainer, role model. So that's where we can uh, like, we can go about it. Next, we can talk about bridging the gap between the trainers. So we are bridging the gap, the knowledge gap between the trainers and the process policies, because probably different trainers have different understanding or interpretation, which is why, because getting uh, like the performance levels are different. So again, you can sit down, brainstorm for all possible solutions. You can introduce a performance link training plan. Uh, Keep this in mind, like a performance link with the people whom they train. Till the time my job is just to train you and you just like then you're on your own, then I would be doing it as a task. I'm done. Bottom line, I train and you're done. But if I link my performance incentive or in bonus plan with the people whom I have trained, I will have vested interest in the entire thing and I will have skin in the game. Bottom line, if you don't do well, you don't make money, so I don't make money. Simple as that. When if you do well, you make money and I make money. That's how it should be. So everyone has a common vested interest so that the production cannot shouldn't hamper. So it's like you can link a performance link plan with the people so that every trainer will give their heart and soul because they have their own vested interest. They would make sure that every person is trained perfectly so that they in turn make money. You can have some anonymous feedback taken for the trainers so that you get to know what's right, what's wrong. So you can give some feedback to the trainer later on. So yeah, you can sit down, brainstorm for all possible strategies or action plans you can come up with. Similarly, for the shift related factors, say we thought about few action plans like rotational shifts to be introduced. So people who night shift probably feel neglected. They're not part of the mainstream. So if you do some rotational shifts, people will be more motivated. They will be able to see a different they'll be a part of the entire scheme. So pretty much that will help. Shuffling of the team probably uh, that will be probably a new change. So every manager has some people reporting to them. We can have some shuffling done. So one manager, the change of managers will probably help. That way, it can help probably. We're just speculating. Uh, Increase of presence of high management in the night shift. Probably that's where we felt it will be a good catalyst to help you motivate people and keep people on the toes. And probably you have some night shift allowance. So people who are in night shift will be further incentivized for doing well. Again, linked with some performance, not just a free thing. This because you're doing night shift, you should get money. No, there should be some added stuff. But yeah, you can have a long list. And trust when you start working on such action plans, the list goes at least 25, 30, 40 action plans easily. uh, Now coming back to the numbers and scoring, what we do here, we're prioritizing. You got your root causes identified, you got your action plans with your team. Now here is where you give weightage to the root causes. So on a scale of 1 to 10, you will sit down with your team, the higher management, the champion, and all those key stakeholders will give some weightage on a scale of 1 to 10, which is more important, which is less important. And that idea can be given to you by the R square, the regression test that you do. That R square tells you how big is that root cause. So you can use those insights to give the weightage. So probably like I got like 70% or 80%. So basis that I would know which root cause is more important, which root cause is less important. So on a scale of 1 to 10, 1 being the low impact, 10 is the maximum impact, I'll give the weightage scoring here. Now, once we're done with this, once this scoring is done, that's when we start like discussing about the other action plans. So we talk about this train the trainer program. If I introduce this train the trainer program, how much impact will it make on the root cause, the trainer? Uh, so generally, it's a good practice to have like this kind of model where we have four different sections. Otherwise, it creates a lot of confusion in the ratings. So if you feel there is no impact, you leave a zero. If there's a low impact, you give a one. If it's a medium impact, you give three, and we have high impact, you give nine. So this model generally is preferred so that it doesn't give you a lot of confusion as to what is because what is different one and two and three and three and four. That's where you will not be able to you not get into that kind of confusion. So low, medium, high sort of impact and no impact is the scale for easy understandings to avoid any conflicts of interest. So we felt that if we introduce this program, it will be a great thing. Yes, so we felt that will have a high impact on the trainer related root cause. And while we were doing it, we also wanted to understand, will it have a cross-functional impact? Although this action plan was made for the trainer, but will it also impact the shift? Yes, it will impact the shift, not directly, but indirectly, because some trainers will be training people for the night shift also. So yes, they will definitely be impacting the night shift. So I'll say there'll be a medium impact on the other one. uh, what if the best practice sharing is done by trainer A? What kind of impact will we have? Well, definitely is the best one will be sharing good insight. So I'll say high impact, and this will also be reflected in the night shift. So as a team, we sit down, brainstorm, give the scoring. Where you feel there's no impact, you give a zero. Where you see there is a low impact, you give a one, medium impact three, and the high impact nine. So you can get the scoring done. There can be difference of opinion. There will be discussions, debates. All in all, as a team, we'll settle down at some score, some number, and we will be able to generate these two metrics. Now, this is irrelevant, honestly, but yeah, let's hear it. Like, how do we get these scores, and what does it mean? Completeness matrix tells you the overall impact of the X given the impact, the weightage, and the weightage of every action plan that you've decided. Impact of X, but we are no longer interested in impact of X because we have moved to the next level already. We're talking about action plan out of those X's. So this becomes technically irrelevant because we'll not be using this. But still, how does this gets calculated? We sum all these ratings of action plans and we multiply the rating with a weightage. That gives me the impact of all those that root cause, that action, that excess. But this is not going to be used the completeness matrix. What we are interested in is the other one, which is deployment matrix, because we'll be deploying, we'll be implementing action plans. We are interested in these numbers. That's why we do a prioritization matrix. We are doing an X and Y relationship prioritization because not the way not all root causes were equally important. Similarly, not all action plans will be equally important. So we need to know which action plan will put maximum weightage, which will put lesser weightage, and that's how we will go about implementing. You don't have like ample amount of time, you don't have ample amount of resources and money, so you have limited resources, limited time, and focus also needs to be prioritized. You can't run in 10 different directions at the same time, so you need to prioritize and channelize your energy, focus, ideas, and everything. So yes, you need to go by the order. So we get these scores. And how do we get this scores? This is uh, say you this is the rating for the action plan multiplied by the weightage plus rating for the action plan multiplied by the weightage. This is the overall impact of that action plan. Similarly, let's figure it out for this. Just another random example. The weightage of action plan multiplied by the weightage of root cause plus weightage of action plan multiplied by weightage of root cause. That's how we get it. Deployment matrix is why we weighting. So highest weightage is we've got these. Second highest probably this one, then third, then fourth. So in the descending order of the prioritization matrix, deployment matrix, we will be implementing these action plans. The action plan which has a maximum impact will be the most preferred ones, because it's very important at this stage to show success. There's always said like they're low hanging fruits. This will give you early success. This is the two people are here more concerned about the outcome of action plans that you will be implementing. A is your management. They're very anxious. They know that you found the problem. Now it's just about fixing the problem. So they're very anxious. They want to see the results. Even your team, they're looking up to you. They want to see the results because they have complete faith in your abilities to lead the team. So you want to show them the right success. They're looking up to you. So it's very important that your team maintains that kind of confidence in your leadership abilities and the way you can bring about the results. So for them to keep motivated. So it's very important to go by the deployment order so that you, it's more like effort benefit matrix. Like efforts, you put in effort for one action plan, but it has multiple X's are being impacted. And we just take it to a root cause. You can have three, four. So one action plan can impact multiple root causes at the same time. So you will see more impact like by just putting one effort for one action plan, you will see improvement in multiple areas, which is why we prefer the deployment version. So that's how we go about implementing the action plans in the descending order of deployment matrix. Is this clear to everyone?
Just small question, actually.
Yeah.
Now here we are trying to find out the different actions and prioritizing with the
Right,
deployment.
right.
But when I see that a quick win, that is the low hanging, whatever,
Mhm.
if that is having less weightage also, less deployment, I must do it also. I must prioritize it.
So if it's a quick win, see, in the end, I need to look at like balancing it with the resources I have. I don't want to open up too many fronts to, because my action plan will be, my focus will be divided. So there's nothing wrong or right. Honestly, again, what the question you asked, doesn't it, this doesn't stop me from doing it. It's just about channelizing your efforts and energies where you get maximum returns sooner. If it's a quick win, definitely I would love to implement, but yes, do I have and that's what these action plans, wherever we get them getting a higher weightage, will have a more impact, will show some substantial results as compared to where I get like this one. Probably I can manage it easily, but I won't be able to show that magnitude of change in the result. So it's just what, like, if you have resources, you can go and implementing all those action plans at one go. But we do not have luxury of so many people to be working on. So we would like to make sure that we can maximize the results in the beginning. When I'm able to execute this, when I'm able to execute this, I'll see a good uplift of my performance in the beginning itself. That will keep us motivated. But having said that, this is just a, if you have bandwidth to execute multiple action plans at the same time, you should definitely go for it. These are just indicators, but ultimately, as a business owner, you have more clarity as to what needs to be done. So yes, there's, see, theoretically things can give you the guidance, but yes, there's certain things which you know, yes, this is something which I can do, and it won't take much time. Probably I can manage 1 hour from here somewhere,
Yeah,
and I can get it done. So definitely go for it. There's nowhere, nothing is a guideline as such. You can definitely go for that. No stoppage there.
right.
Yeah, perfect.
Thank you.
Thank you. So once your action plans are done, you are ready to implement. Your action plans are ready. You will go ahead and implement these action plans. Team is ready, but you would not be allowed to go ahead and implement this action plan straight away right now. Everything is ready. The action plan, the priority, everything is ready. But we will go back to risk management plan. That's the most critical part here. You are ready, but you don't want, see, at this stage, you got to keep this in mind. Your action plans, you have a business problem. This business problem, which is your why, is linked with root causes, and these root causes are linked with your action plans that you've created. Now, if this action plans works, your root causes will improve, and your root causes improve, your business problem will improve. So you want these action plans to work. You cannot afford them to fail. They must work. So in order to ensure that they must work, we must safeguard them. Every action plan has tendency of failing. Could be potential failure, which can spoil everything. I don't want, because I cannot afford these action plans to fail. Hence, I must update my risk management plan, which is FMEA, which is failure modes and effects analysis. Now, this is not a Six Sigma tool. This is a risk management tool which is used in practically all the ISOs. We have this thing. You look at PMP syllabus, you will see FMEA. FMEA is risk management tool. Keep this in mind. FMEA, we are talking about updating the risk management. So it's not being created here. FMEA you would have created in the define phase itself. FMEA just helps you to manage all possible risks, how my uh, process can get into a failure. Any action plan could fail, and according to the action plan failure, I would like to protect myself. Like one of the biggest failure happened, which is this COVID thing. Everyone was taken aback. Nobody was planned for this risk. Nobody had a clue of this word called pandemic. Again, this is a new term for our generation, for everyone. Like probably we have never thought of this thing. Everyone is confined to homes. It's a big risk. Nobody even thought of it. So we don't want any such failure, or for any failure for that matter, to spoil those action plans, because those action plans must work. So it's like vaccination of those action plans needs to be done upfront before you implement them. Before you implement and execute your action plans, you don't want those action plans to fail and then you look for a solution. No, I'll vaccinate those action plans upfront before I implement them. That's where you will go with FMEA. Now let's have a look at FMEA. The templates could vary a little bit here and there, but different companies can kind of end up making the sample template differently, but more like the basic ingredients remains the same. So let's have a look at this again. First, we talk about the identified X's, the X's that we found out. These action plans were picked up from X and Y relationship matrix. So we got all those action X's and the action plan, X's and the action plan, whatever we got from the previous stage of X and Y relationship matrix. All these, the X's and the action plan, we bring them to this FMEA template. Now, next tab says failure modes. In what all conditions can this action plan fail? So we talked about train the trainer program. Well, if the person who is supposed to train, that person is inefficient, the master trainer, that person is inefficient. Has this happened? No. Can it be a case? Yes, definitely. Why not? There could be a master trainer who's not efficient. Probably, yes. What if attendance issues are there? People are not coming for the training. Well, that can be a possible reason. Your purpose of having this trainer program will go in vain. Unavailability of trainer. The trainer himself is not available. So this will not happen. So that's why, has this happened? No. Can it happen? Yes. Then if it can happen, I must know it. And I will prepare myself for it. So I don't want to be in the situation where I'm starting to look for solutions later on. I will plan ahead of that failure. Best practice sharing to be done by the trainer A. Well,
Mr. Sassi,
yes, yes.
these failure modes,
Mhm.
means from where we will get, actually it is from the
We'll brainstorm
brainstorming.
the
Yeah,
same team.
brainstorming, right?
We'll brainstorm and see. There are a lot of insights to it. You can look at historical reasons. Your experience will tell you your process based on the entire team discussion, all relevant. When this X and Y relationship matrix is being done, all the relevant stakeholders are called, be it your your champion, your process owners, your quality team, your training team, HR team. All relevant stakeholders will be a part of this when you're constructing this X and Y relationship matrix, and when you're kind of thinking about all possible failure modes. Anyone who has a vested interest in the process must be part of this session, because we must ensure that we must brainstorm for all possible access, but trust, you will never ever be able to get all possible risk. We can anticipate, but we can never say that we got all of the risks. So FMA will always be incomplete document. It will never be marked as complete. You can never ever think and plan for all risk. Risk will always be there. Like this COVID thing emerged as a new risk all of a sudden. So no FMEA can ever be marked as a complete document. It will never be complete. It will always be updated. It's the only live document which will never die. Project starts, FMEA starts. Project ends, but FMEA never ends. Risk management will always be done. So there will be new risks which will come in future, which we have not even thought of. So we talked about, like, say, the trainer A, best trainer, role model. We're telling everyone you should be like this person. Well, what if this person resigns? Has this person resigned? No. Can he? Absolutely yes. We can't. This person is not a bonded person. So pretty much, if there's ego issues by other trainers, other people doesn't want to hear him. Well, you, my colleague, why should I hear you? You're not my boss. Well, other people can have challenges. Has it happened? Practically not. But yes, can it? Definitely yes. There could be possible ego issues. What if the trainer A is reluctant to share? He doesn't want to share. I am the best trainer. I have worked hard for it. There's no charity going on. Why should I share my best practices? Well, I am enjoying this luxury. Everyone wants me. And like, I have worked hard for it. Do you want me to just create competition because you have a project? It's a human tendency. Why would I do it for, like, just to create competition for myself? Well, that can be possible failure. In every action can fail, can because of multiple reasons. We just for an argument's sake, we're just picking 3 4 3 4 here, but like, just take an example. We've got, like, say for example, you have got on average, like, so on average 30 action plans. In every action plan, if it fails because of just minimum three reasons, you have 90 possible failures to manage first before you go ahead and implement 30 action plans. You have 90 risk management plans to be implemented first, before you implement the 30. So this list can go, this is an exhaustive document, because you'll end up kind of thinking and brainstorming for all possible failures. You have a long list of failure. Like, we're just kind of going with this. Now the next topic comes in, which is effect on EDR. EDR stands for end desired result. What is the expected result from this action plan? You wanted this action plan to be done, like train the trainer program. If this failure happens, what will happen to that expectations? Will it still be the same? So generally, if I talk about, you can write it in like different words. It's not like you have to use a specific word, but you can draft your own version here. You can write it in like sentences to explain what is the effect on end desired result. But all in all, what we have seen looking at various interpretations of FMEA, generally outcomes can be of four types, and you can think of more also, but we've just generally seen like there are four types of outcomes of a failure. Either it will be a fatal error, it will be absolutely bad, the entire impact will be cancelled, it will become zero, so it won't, like trainer A resigns, my role model, I've been telling everyone you should be like this person. What if this person gets a salary, doesn't show up next day? My entire purpose will fail. Fatal error, result will be zero, nullified, impact gone, all that purpose will be lost. That can be a possible impact on undesired result. Or probably the results maybe get delayed. I wanted results in say 5 days, 10 days time, very quick results. It might take 2 months, 3 months for us to see the improvement. Yeah, results might get delayed, like attendance issues. I don't have people coming, so training may happen, may not happen. So some people will come, not come, sort of thing. Unavailability of trainer, delayed. If the person is not available now, next time, whenever training, so the results will get delayed. So results may get delayed, whatever you expected results you wanted, or it may be reduced. You wanted 100% results, impact. You might get like 10, 15, 20% results. Impact may be reduced because of that failure, or altogether it may have a negative impact. Forget about getting a positive impact, it may negatively hurt the entire process. Yes, it can. So all in all, look at the possible failure and see what kind of impact will it make on the expected results. You had some expectations from the action plan. What will it do to it if failure happens? Now, as a team, we'll sit down, they kind of finalize it. Now comes with the three critical elements: severity, occurrence, and detection. Your FME works on these three components, S, O, and D. Now, we have a scale which is from 1 to 10 for everything. Severity is rated from 1 to 10. Occurrence is rated from 1 to 10. Detection also. Severity of 1 means not that critical. Absolutely, it's normal. That's not a big deal. Small failure. It's not that critical. 10 is fatal, absolutely fatal error. So it's a this severity is going to be rated on 1 to 10, 1 being really really bad, 10 being really bad. 1 is not that big deal. Okay, it's okay to have that kind of failure. So when you look at this kind of failure, inefficient trainer, do you think it's like severe? Yes, as a team say we feel no, this is really bad. The entire purpose is lost. So severity is 10. Say attendance issues, we feel okay. Sometimes somebody will come, somebody will not come, somebody has to leave early. So all in all, it is not a very very big failure. Yeah, but more like people will be coming at times, will not be coming. So severity is there, but not that big deal. So I'll say as a team we settle down at 6. Unavailability of the trainer, well, the person is not available today, maybe after, like the trainer may be available after a week's time. So it's not a very big problem. They probably will be dealing it by a week. Severity is not that critical. Trainer A resigns, well, that's really bad. My entire purpose goes for a toss. So practically severity is on a scale of 1 to 10, 1 being low and 10 is really bad. Occurrence on the same way. How frequently do you think this failure can happen? Say inefficient trainer, if you are inefficient, you are inefficient, simple as that. Every time you'll take the training, you'll spoil the training. So occurrence of this failure will be very high. And if you're inefficient, you can't change overnight, so occurrence is high. Attendance issues, again, not everyone will be absent every day. So occurrence, say out of 10 training sessions, probably couple of sessions everyone might miss on different days. So occurrence of this failure can't be every day won't be there. So occurrence is less, depending on whatever. As a team we sit down and discuss. Unavailability of the trainer, very less. Always the trainer will not be always absent, so chances of this failure is very less. Trainer A resigns, you can't resign every day, so 1 only. Ego issues, well, I have a problem with you, I'll always have a problem with you. We don't gel each other, so gel up with each other. So I'll always have cold vibes. I'll not pay respect to what you do. practically I'll have my reservations. I don't want to talk to you. Simple as that. I am forced to sit in the session. I will sit. That's how it is. So what is the probability of that failure happening? There will be the occurrence part. Now, if you have any historical evidence to support these ratings, please mention. Like you have seen prior training sessions, there were some absenteeisms. So if you have prior evidences that you can share, if somebody asks you what is the reasoning behind this rate, you can mention that. If you have any, please do mention it. So moving to the now, this is where it becomes a little tricky, and we have to keep this in mind. Uh, it works on a scale of 1 to 10, but detection works a little different. Now, if a failure happens and I'm able to detect the failure instantly, immediately, that's not a big deal. It's a simple failure. I'm able to find it. Like you're sitting in a room and there is a power cut. There's no electricity. All of a sudden, this detection is there very fast. You know there's no power. Instantly you will do something. You'll switch on the power backup or do something about it. Detection is immediate. Not that big deal. You can do something about it when you detected the failure. The problem is when you cannot detect the failure. Failure has happened. You're living with the failure and you have no idea. And could not be better example than this COVID situation. When they started in the specifically in the European countries, it was very evident somebody was having a high fever, breathing problem, all those stuff. Again, it was detectable. You can spot this person having a problem. You can do something about it. You can take this person to the hospital. You can put in quarantine. Do something about it. Detection was easy. The person was showing evident signs. Risk was not that big. When you can detect failure, you can do something about it. Risk was less. When risk is less, I'll get a low rating. But now, what the way things have emerged, uh, COVID, like a lot of most of the cases are asymptomatic. People are not showing any signs. They are Some people are absolutely healthy. They have no signs of any discomfort, but they are carriers. They themselves don't know that they are carrying COVID on their body. They're just spreading it everywhere. Probably their immunity is good, so they are not getting infected, but they have become carriers. Detection level zero. You don't know who's sitting next to you. This guy has got COVID on his body, then it's completely infected. His body is able to resist. Well, I don't know whom I'm kind of dealing with. So detection level is zero there. I can't detect. It's very, very fatal. It's very bad. So when you cannot detect, then it's a 10. It's a bad situation, highly risky. So keep this in mind when you talk about detection. It's a risk. From the risk perspective, if you can detect it, it's not risky. If you cannot detect it, it's very risky because you're living with the failure then. So like inefficient trainer, you can detect it easily. First session, 10, 15, 20 minutes, 30 minutes tops, you should know, well, this guy doesn't make sense. Well, attendance issues, I can get to see how many people are attending it. Unavailability, you get to know instantly. The trainer is not available. Trainer resigns. Instant detection, you get a resignation email, SMS, whatever. Uh, well, this is where my problem arises. Trainer is reluctant to share information. Well, keep this in mind. This guy is the best trainer, and he is a smart one also. So boss has asked him to share the best practices. He's not going to tell to his boss, well, I don't want to share because it's my hard work and everything. Why should no? Look at the choice of word. Well, you want me to kind of spend daily 15 minutes with them. Well, I don't think that's sufficient. I must spend at least 30 minutes with them. As a team, we should do well. Well, look at the choice of word, body language. Absolutely, like you can't detect. It's like deceptive. Well, the person genuinely will never do it, but detection is not there. I can't figure out this guy has got a apprehension. He's very smart with the choice of word, the body language, but he's just going to spend time, come back and say, well, sorry guys, these guys are bad. They don't want to work. Practically God knows why they're like, they should understand what's the company values, this and that. Well, detection is low, simple as that. This guy is deceptive. I can't detect his, like, whatever the shrewdness or whatever say. The detection is low. Now, when I get my detection score done, I move on to the RPN, which is risk priority number. This is how we identify the priority of a risk. How do we get RPN? It's a severity multiplied by occurrence multiplied by detection. So we multiply all these three: severity multiplied by occurrence multiplied by detection. It gives you RPN, which is risk priority number. So your risk priority number can be minimum of 1, which is 1 multiplied by 1 multiplied by 1, or it can be maximum 10, 10, 10, which will be 1000. So RPN will always be between 1 and 1000. That's the range of RPN. Now, basis the RPN, we will select which is most critical risk, which is less critical risk. In the descending order of RPN, we will be fixing the risk, the risk in this. Now, you can have few conditions which can emerge in RPN. If you get a tie in RPN, two RPN have exactly same number. That means now we need to understand which one will be fixed first, which one will be fixed second. First, whichever has highest severity will be chosen first. If you get a tie, then you choose for the highest severity between them. And if you get a tie in severity also, then you choose for which one has got highest occurrence. So first, highest RPN. If you get a tie, then highest severity. If you get a tie, then you get for highest occurrence. That's how you you use your RPN, risk priority number. Now I know every risk. I know in which order I need to manage the risk, because this is a long list of possible failures. I need to manage them. I need to get them fixed. But I need to understand this, how I'm going to manage the risk needs to be identified. I know the number, I know the priority, but what are the ways you will be managing the four types of risk management system? RMS stands for risk management system. Now we need to understand the meaning of every risk management system, because for every risk you have to choose one, either of these. All of there are four options. For every risk you have to mention how are you planning to manage the risk. Which one are you going to accept the risk? Are you going to avoid the risk? Are you going to reduce or mitigate the risk? Or are you going to transfer the risk? Four types of risk management. So every risk you must have one of these. Let's understand the meaning of it, and accordingly we will use the RMS. Now, risk management system, accept will only be chosen when you genuinely cannot do anything about it. Say, for example, again, the COVID situation, nobody wanted to stay at home, everybody wanted to work, but we were confined. Regulatory requirements, everything, people, government passed on regulations, you have to be at home, or well, practically, and you couldn't do anything about it. You had to accept the risk. So when you genuinely cannot do anything about fixing the risk, you have to accept it. Say, for example, you wanted to motivate people in the night shift. You wanted to do some, bring in some extra incentive for the night shift people. You wanted to run out some contests, like to motivate people. Well, management says no budget. Can you fight with the management? No. You have to accept the risk. So when you cannot genuinely do anything about fixing the risk, you have to accept it. That's only when be honest and truthful to yourself as a group, that can we do anything to fix this, because we don't want to accept the risk. Accepting is means that I'm okay with the risk. Let it happen. When it will happen, we'll see to it. I have not, like, honestly, I have nothing else to say about this, because I have no control over this. When it happens, it happens, and we have to bear the consequences. So I'm okay with it. I'm declaring it myself well enough, well in the beginning. This risk hasn't happened, but whenever it happens, we have to bear the consequences. So it's the worst thing you can do is to declare yourself here that I'm okay with the risk. But yes, when you genuinely cannot do something about it, you have to accept it. So you have to choose when to use accept as a team. Avoid probably is even worse than accept. I will say that probably, yes, technically this is even worse than the accept. Here is all about priorities. Well, when I'm saying choosing avoid means, well, I know in the first case, at least I was okay when I was prepared, that I've declared I am not going to do anything about this. So no action plans for this. I have accepted the risk, let it be. Avoid, I'm not saying no, it's important, I know it's very important, but I right now I have two more things to do or three more things to do, I look into it. That day will never come. It is not on your priority list, it will never be on your priority list. So when you're avoiding a risk, you postponing it for some other later date or time, you will never do it. When you choose to avoid risk, it's even bad, because here you're not prepared for the risk. You want to fix the risk, but it's not on your priority list. So it's a worst thing. At least in the first case, I'm prepared for it. In the second case, I'm not even prepared for it, but it's just not on my priority. But some companies have different criteria. So we have done consulting. We've seen different companies use different cutoff criteria. Again, it's okay to use avoid also. when your RPN is very, very low. And now, what is the definition of very, very low? Different companies have constructed like different kind of cutoff limits. Some companies we have seen that they say if it's less than 16, it's not worth putting in effort on that. Some companies use a criteria of less than 20, depending on what your organization uses. They say that the RPN is so low, that means severity is very low, not that critical, not that big deal. Occurrence once in a year sort of thing, not a big deal. And detection is very easy. So that's when your RPN will be very low. If your RPN is very low, then you can choose to avoid it. Whenever it happens, we'll be able to still fix it again. So not a big deal. So you can use it. It's not worth to put time. So I can avoid it. Avoid can be chosen, but in generally most companies use less than 20 as a criteria. If your RPN is less, then you can, it's okay to avoid that. Still, I would like to fix it, but it's okay to avoid, given that I have priorities to look at. I can look at it later. So less than 20 can be used as a criteria, depending on what your organization uses. In most of those RPNs, like on your, you will generally be seeing this reduce. You want to reduce the risk. That's my purpose. I don't want to live with the risk. I want to reduce it. You want to mitigate it. So here you'll have action plans. In the first place, no action plan because you accepted it. Avoid when you're avoiding, there's no action plan. Here you will have action plans. And in the transfer, transfer is also absolutely okay. You can choose that transfer because it's better than reduce. Definitely, you when do you use transfer? When you have somebody more capable, somebody who's a subject matter expert out of the project team, can be like you can transfer your risk to somebody more capable. Like for example, you have banks. Banks are financial institutions where they have to put cash into ATMs. They don't do it themselves. They have hired a security agency. They don't they want to become a security agency or some security company. They are financial institutions. They want to keep the job up to that. So they transfer the risk of money handling or like so to a security agency who's more professional, more like skilled to manage that risk. Like we have birthday parties, we have marriages, functions, events. Can't we manage it ourselves? No, we can, but we prefer an event manager to do that. Why? Because that person is more capable. We get consultants from outside to do the various trainings and projects within the team. Why can't we do it? We can do it, but we prefer somebody more capable, professional, expert in that particular domain to do it. Yeah, so transfer is absolutely fine. Still, you will have not have no action plan because you have transferred the risk, but it's okay because somebody is more capable than you is managing that risk. So it's fine, but it comes with a cost. So management has to approve that cost. If they approve, well, it's okay. But if they don't approve, then you pretty much would like to reduce it. So transfer is absolutely fine. Keeping there's a cost because you're transferring the risk to somebody else outside the project team. That will come with some money, some cost. Now, wherever you chosen reduce, you want to reduce the risk, you have to have an action plan. Now, action plans will be of again two types. RTP, wherever you chosen reduce, you must have two types of action plan. One is a preventive plan, one is a contingency plan. Now, preventive plan is like before the risk has happened, you need to have plans which will ensure that risk don't happen, like the failure doesn't happen when and contingency plan will be the ones which will be implemented, which will come into action once your failure has happened. So one is before failure and one is after failure. Now, for example, like there's a office premise and a factory setup or whatever. We have a risk of that there could be a fire outbreak, short circuit, electrical short circuit or something like that. Now, what's my preventive plan? My preventive plan is that I should be doing a regular maintenance. I should be doing a regular audits to make sure that everything is in check. There's no hassles. Like pretty much we've covered ourselves. That's my preventive plan. It is greatly going to ensure that there'll be no fire outbreak. But does it guarantee there'll be no fire outbreak? No. So yes, what if it still happens after regular maintenance, regular audits? It's what if it still happens? What's my backup plan? Well, my backup plan is that my staff is trained on fire mock drills. My staff is well versed with how they need to act in case of fire outbreak, when to use water, when to use sand, where to use what. The number for fire brigade is displayed everywhere. Plus we've done the insurance for the building and everything. So bottom line, that's my backup plan. What if it still happens? That's my backup plan. So every risk must have failure must have two types of plan. One is preventive plan to prevent the failure. And what if it still happens? That's my backup plan, which is contingency plan. Like for example, we had a risk. What if my trainer A resigns? Well, this guy hasn't resigned, hasn't shown any signs, but can he? Yes, for sure. So what's my preventive plan? Well, if this guy is really good, can you afford the person to promote the person? You can do that if in case that's the case. Or else, why not have somebody from higher management come and appreciate this person in open, or call for a meeting from higher management, just a 5 minutes meeting. The choice of words coming, like the words coming from this person, like probably CEO of the organization calls in for a quick 5 minutes conversation, telling you that we have been noticing your growth in terms of the way you do this stuff. We are really happy to see your like the way you deliver these things, and we see great you dealing with important stuff in future, and all that stuff. What like words of appreciation can do great wonders coming from somebody higher up in the management. It didn't cost anything for you, but this will make sure that this guy is like connected with the organization. You like the person has feels that well, the management appreciates me. You kind of ensuring that the thought doesn't come into the mind, because this you've shown the person a bigger picture, a role that person will be managing. You kind of mitigating it, you kind of preventing the failure, because you want to make sure that the person feels connected. You don't can't afford this person to lose this person. It's a pretty much very good resource. Have some rewards and recognition. Have this person like if the person is really good, some sort of certificate or whatever you want to add, that will be part of your preventive plan. What if it still happens? Well, I don't want to be in a situation where this guy still leaves my organization, somebody joins somebody's other organization with double pay hike. Well, that's absolutely possible. So I will start creating a backup right now. I'll have a couple of people who will be like working as a buddy with the person to understand the way the person manages it, give a dotted line reporting to him, not on paper, but just give the person a responsibility. Well, you need to learn about the team handling skills. These are the two people assigned to you. Help them understand this and that. Give the dotted line reporting sort of thing, the term they use. Now, pretty much have backup created well in advance. Well, this we cannot afford this person to leave, so yes, let's ensure that we have enough backups. What if this person still leaves? We know that we can start anyway. So risk treatment plan will cover both the aspects. For every action plan that you've got, you will have your responsibility assigned to it and a deadline, because keep this in mind, you have not implemented your action plans yet. You are waiting for the action plans to be implemented. So yes, your response or every action plan will be given a responsibility who will complete that risk management plan and with a deadline. So once this is completed, that's when you can go and implement your X and Y relationship matrix. Now, pretty much the last thing in this, you'll see generally three types of FME. One is a DFME, PFME, and SFME. FME is an FME. People have started giving a different nomenclature. DFME stands for design FME. When I start speculating for such failures, what can go wrong with my design, that's my DFME. The one which we made just right now, this one is PFME, process FME. What can go wrong with my process? SFME is used by software or system. So the concept remains the same. It's where we are using it, they're using a normal like initials for that. But FMEA is an FMEA. So there's nothing other, like people have started creating more versions into it. But it's more about ensuring that you plan for risk, you brainstorm for risk, you update your risk accordingly, and you know how you're going to manage it. You will find new risk. As you find a new risk, you'll keep adding to this particular document, because it's a live document. I will never be marked as complete. So that's how we go about FME. Anyone has questions about FME?
None on my part.
Okay, Sanjay, you have questions?
FMEA, we are actually uh, measuring the impact and the risk also. Now, when we declare ourselves close to with this issue, we are done.
So basically,
It means we are measuring the effectiveness of the implementation.
Okay.
So through the risk analysis and all.
Yeah, so this will continue hereafter also.
So this will be following a Deming cycle.
Yeah. So this is how it is. The next review date. So that's what, like, once we have ordered, like, I would just want to another talk about another couple of minutes on this. But if you have understood this, because as I said, it will never be never marked as complete. So this is the portion which I would like to talk. So yes, we will never mark it as complete. So once we've done this, my FMA gets implemented. But uh, over after, let's say, you can decide every review period, because risk will keep coming, risk will keep getting added to this FMEA. So probably say this is today's date. So if we decide like every quarter we will be doing this FMEA review exercise, so after 3 months date we can put it. This will go like to like it'll go on right on the right side, it'll keep on moving on. So let me just give me, okay, here. So this will be next 3 months date, and similarly it will follow on. But keep in mind, now the review FMA happens, severity will not change. Something was severe will still remain severe. It was whatever the severity was, we have just copy pasted 10 and 6. This failure, we still have the same severity we have marked here. Uh, Secondly, we have but by the word, so something which was fatal, something which was severe will not change. The only thing which would have changed by the virtue of your action plans, your strategy, we will be able to reduce the occurrence. Something which was occurring very frequently will be occurring less frequently now. So we would have reduced the occurrence of the failure. Something which was not detectable, we would have made it detectable. So see, the severity remains same. We have mentioned occurrence 2 and detection 2. So this is where we because of the action plans, the strategies you made, your occurrence and detection has gone down. Severity, something which was fatal, will still be fatal. Um, the severity can't change. If it was bad, it is still bad. It will always be bad. Yes, I can reduce the occurrence and I can make it more detectable. So it says residual RPN, left out risk in the system. You can't squeeze out every possible risk. So it will keep moving on. And then RMS, what is your new RMS, new treatment plan, and the new risks which have been identified, which will continue. So after the next 3 months, we'll have another review. So that's how we continue going. So this, it goes on and on and on along with this.
Let us imagine a situation that your business condition changes. Maybe some business risk will be mitigated for some scenario because of the pandemic.
Right.
Your severity changes there.
So you will not. So what you will do is, if in case so in case of FMEA, it is never. So basic term, we have to keep this in mind. In FMEA, you don't never. Let me just mention it here also. FMEA is never appended, sorry, never updated, but appended. You have to keep this in mind. You'll never replace what's there in there. So you can mark that particular, what that thing has changed. You'll mark that column as like you would not delete or update. Like severity will not change. It will always, once a part of FMA, it will always stay there. You can mark this and update the comments there somewhere here that it is the things have changed, and you'll add a new row for that, new risk, whatever. So that will never be deleted. So FME, you can never update. You could update means you'll never be changing something. You'll, whatever value gets added in it stays there. You'll always append to it. You'll always add to it. So yes, if you, in case the business conditions and strategy, the basic fundamentals have changed, I may mark this as not applicable after that, and then I'll create a new row for the due risk the way it has been identified. So it will never be updated. You will not replace it. You will append it. You will add to it the existing information.
Clear.
Okay, perfect. So once your risk management plan is covered up, you are ready to go ahead and implement these action plans which have been waiting to be implemented, but we could not implement them just because we had to kind of ensure that all those basic elements are covered. Now my action plans are safeguarded. I can go ahead and simply implement these action plans. So that's where we start with the implementation part of it. Uh, we never go full throttle. You don't implement all the action plans at the same one time. So you always go on a pilot mode, a small scale, and you want to test and see, is it improving my business problem on a small scale? If it is improving, then I have got a perfect strategy which can be rolled out for the entire process. So I would like to test on a small scale and check, is it working or not, a prototypes kind of thing. So we have identified solution, now we'll be implementing them. How do we check the improvement? Did it improve my process or not? So we check improvement with the help of a test by the name of one sample t-test. One sample t-test will be used for validating, did your process improve or not. So let's have a look at the test result. So we have one sample t-test and paired t-test. This is the one. Okay, just for an argument's sake, we have like we picked up a project to increase the daily productivity. Management had expectation that we should increase the daily productivity greater than 425 kilograms per day, whatever may be metrics. This is for example. So we were given this target. We had taken this project to increase daily average productivity more than 425 kilograms. So null hypothesis always comes with equal to, says no, it's equal to 425 kilograms. Alternate will always come up with greater than, less than, not equal to kind of thing. So this is what we wanted to prove to the management, that my strategies, my action plans were so good that we have increased your daily production over 425. Let's see if we meet the target, expected target or not. So what we have done is, like, we would have implemented the action plans, and we would have, after implementing the action plans, I would have say after 1 week, you can choose after every 10 days, after every 7 days, at what frequency you want to check the progress of the project. So say at the end of week 1, you don't have week 2 and week 3 data. 1 week of implementation has been done, your strategy has been implemented. You want to check, is my action plan working? Did I achieve my target or goal or not? So you collect some sample data and you check with this test. One sample T is here. Stats, basic statistics, and one sample T. You click on this one sample T. Here's in this box, we click. You will just have week 1 data. After 1 week, you select it's week 1. It says perform hypothesis test. Check this box. It's asking what is the target. My target is 425 kilograms in this case. Option, what is that you want to prove? Alternative hypothesis, what is that you want to prove to your management? So I've got 3 options. As I said, alternate will always come with 3 options: less than, greater than, not equal to. I want to prove to the management that average is greater than 425. Hypothesis mean is 425. So I want to prove that my strategies were so good that we've changed the DNA of the process, actually like improved beyond 425. Mean is greater than 425. Hypothesis mean 425. Let's see. P-value says null. Null means not improved. Alternate means it's greater than 425. Null says equal to 425. So we have not improved. 425 is still a far number. P-value confirms us that it's null. Null means no improvement. Alternate means yes, this has been proven. Let's see. We'll learn from the mistakes. We'll implement, revise our action plans. We'll revise our risk management plans. The people will get together, see what went work, what worked for us, what didn't work for us. We'll again revise the strategies. We re-implement, and say at the end of week 2, we again, nothing is going to change overnight, so it takes time. So at the end of week 2, same stuff. We want to check 425. Still want to prove that it's greater than 425. We check okay. Still getting a null. It's not less than 0.05. So the target has not been achieved. Let's have a look at week 3. So we keep checking at whatever frequency level. Here I have a statistical validation that this process has improved and greater than 425 has been achieved. This is where we're saying, come back to the same question. This is just a sample data, but at this level of p-value, looking at this p-value, I can say that DNA of the entire process has changed. Should you pick up a new sample? Should you add samples? Should you reduce sample? Change a different sample? You'll always be greater than 425 as an average. Always, you'll have an average of the sample of the process greater than 425. That's what this helps me understand and predict for the entire process, not for the sample. So now you know that this is how it's done. Let me just put together all of it to kind of give you a clear picture. How do we present this to the management? Week by week progression, which will be able to show week 1. So you'll have your whole historical week data that you've tested on. This is where we start getting into the presentation mode, because here you've got a perfect analysis which tells you, yes, this target has been achieved. Now you want to seek an approval for full-scale implementation. You want to tell the management that yes, we want, have you got the results? We have a perfect strategy. We have a perfect risk management plan, which will help us ensure the project is achieved, like the target is achieved. We have improved on small scale, but you have to show some evidences to the management. So you have to submit this project progress report. So this is more like a presentation, PowerPoint presentation stuff that you have to present to the management. First is the project progress report, which is one sample T1. How you will present it? You put together all the data for week 1, week 2, week 3 with the same 425 as target. Mean is greater than hypothesis mean. That is what you want to prove. Click OK. Now that's a complete thing, and let's interpret this, and we'll be able to understand why and when it happened. Like, let's have a look at this. First, week 1, we got null. That means we did not achieve this greater than 425. Week 2, null. Did not achieve. Week 3, it says alternate. That means greater than 425 for the entire process has been achieved. Although we picked up a sample, but it's predicting about the entire process. We have changed the DNA of the process. It's now always going to be more than 425. Let's see the reasoning behind it. Week 1, you picked up 19 samples. Those 19 samples had an average of 237 as an average against the expected average of 425. What it says that just 19 samples has an average of 237. What if you increase the sample? Will this average change? Yes. What if I pick more samples? Will it change? Yes. What if I change these samples and pick a new sample? Will it change? Yes. So what it says that we're 95% confident that your process average, whenever you pick up a sample, increase sample, whatever sample you do with the sampling stuff, we're 95% confident that your process average can go lowest up to 224. So lowest worst case scenario you can go, you will find in your data, as per this data interpretation, your process average can be lowest up to 224. That's what it means. In the week 2, we had a sample of 354 as an average. What it says, we're 95% confident that lowest the average of your process can go up to is 330 kilograms per day. In the week 3, it says lowest you could go is 442, which is any given day more than 425. That's how it helps me understand that yes, this is where I got, because any given day I will be lowest is 442, which will always be over 425. Is this clear? Week by week progression.
Yes, sir.
Okay. So because you got this on a one PowerPoint slide, you this particular thing, entire thing, you put it on one PowerPoint slide, which shows the journey of your project. It could be like week 3, week 4, week 5, week 6, whatever number of weeks, but it will show a complete journey, how you progressed week by week, week by week. And thereafter, now because you know there is a process which has improved, now comes the comparison test of before and after, because everything needs to be compared and shown to the management how you have, what difference have you brought to the table. So before and after test. So I'll change this to old Y, where we started from, and I'll make this new Y, so where we improved. I have to showcase the improvement. So let me just delete this. Ideally, it's not required to delete, but let do it. Yeah, old Y, new Y. This is where we started from. This is where we improved. The test which is used is parity globally. Everyone uses parity test. Now, even these COVID vaccines, they are going through parity test. Every test, what it says, this is before and after from the same thing. Say, when you compare, keep this in mind, when you compare two independent population, like average of two groups like male and female, they are independent population. Average of morning shift versus night shift. You use a two sample T. It's independent populations. Average of two independent populations, male, female, manager one, manager two, morning shift, night shift. But when you're comparing dependent population, it's always before and after. Average of old versus average of new, of the same thing. Like you see this weight loss program. The earlier guy is like fat and then transforms into a very lean person. Before and after of the same person. That's paired T. All the drug testing companies, all the medicines, they have to go through regulatory requirement of proving it through paired T tests. In the vaccines that's been done, paired T test is done. Before the person, somebody who's got infected, you give them you take down the antibodies count and all that stuff, and then after you give the vaccine again, you check using parity. Null definition says there is no difference, you're old and new, they're same. Alternate says no, The new is different from the old. They're statistically different. That's what alternate will always say. But keep this in mind, this is for the same person, old and new. Old and new, if I say the same case of a psychiatric treatment, the doctors will take care of all those vital signs, body, heart rate, and all that, all those stuff. After psychiatric treatment, they will again measure this. What Null says, psychiatric treatment has no role to play. Old and new vital signs are same. Alternate says no. The psychiatric treatment really worked well. The after psychiatric treatment, things have kind of improved. So how it will be tested? Using parity. Parity is always before and after of the same person or same process. So here we have before and after of the same process. Null says there's no improvement. Old production is same as new production. Alternate says no. There's a huge difference and there's a statistically significant difference between old and new. Let's see parity test. Stats, basic stats. It says paired T. It says determine whether means of two dependent groups is they differ or not. Click on pair T. First sample old Y, next sample new Y. Old Y, new Y. Old Y 237, new Y 463. There is a difference. Yes, there is a difference. But is this a large difference? Yes, the differences are large enough differences between old and new Y. So parity test will help us understand whether the differences in old and new, they are statistically significantly different. Yes, this confirms the same. P-value, alternate, yes, there is difference. Along with this test, the complementary chart will be box plot, but different box plot this time. Graph, box plot, we have been using this, now we will be using this. Y1, Y2, old Y, new Y. Put in old Y, put in new Y, go to scale, reference line. The target was 425 kilograms. We put in 425 here. Just for looks, this is not a requirement, it just looks, it looks clear. Go to data view, connect median of those two box plots of old and new, median connect line. Just looks good, clear. Click OK. Old Y, less than 425 altogether. Shift in the production, clearly visible, clearly visible how you've transformed the new Y. So whenever you do a parity test, this graph will be will work as a complementary chart. So parity test along with this box plot will be used. In before and after, you have got few stuff to this week wise progression, then before and after, then you have box plots before and after. Then you have two more charts, which is before and after control chart. We haven't studied it. We will be studying it in a moment, and we'll be comparing before and after sigma levels also. So when we compare before and after sigma levels, we by default get before and after control charts. So let's do a before and after sigma level, which will bring an end to this improve phase, because this is where we're kind of seeking an improve. We got a perfect strategy ready. So we go to assistant, says before and after control charts. We don't want to do it because it will be done automatically in the capability, the sigma level. We go to before and after capability analysis, and it says data type continuous. Yes, we have got capability comparisons. We click on this. It says baseline process data. That means your old data where you started from. Click on this box, old Y. What is subgroup size? 1. Always default 1, single column. Improved process data, the new data, new Y. Subgroup size 1. Customer had a minimum requirement of 425 LSL, lower specification limit of 425, minimum of 425. That's it. Click OK. It says there's a 77% reduction in the defect. Earlier, your defect rate was 100%, and now it's gone down to 22.89%. That's the drop in your defect rate. Now you still have 22.89% defect, but it's dropped from 100%. If you look at this chart, it will give you old sigma level, new sigma level, change in the sigma level. This was the minimum 425 target. Everything was below 425. How your process has shifted, it tells you that. You want to add some comments in here, make some notes, personalized comments for your management to look at. What you just type in here and just save it. It just stays there. It says there. So these are ready reports for you to share with the management how the changes happen. Control charts, old control chart, new control chart. We'll be discussing when we start the control phase. But it's clearly done. Normality test, old data, normal data, new normality test data. It tells you the normality test data also. results. This is performance report comparisons. Your CPK, old sigma level, new sigma level. You have to add 1.5 to this to get you current sigma levels. So this plus 1.5 plus 1.5 to get current sigma. Z bench is your long-term sigma. It tells you your defect rate was 100% has gone down to 25% here. So pretty much you can see this, like this is the comprehensive reports which are ready for you to share with your management. These are enough evidences that you share with your management to tell them that yes, your process has significantly statistically improved at this stage. So when we're working on sharing these insights with the management. So you have your week-wise project report, you have paired t-test along with the box plot, and you use the sigma level, put them on a PowerPoint slide, share with the management to seek an approval, uh, because that gives them the confidence that yes, uh, you have improved it. There's a validation to seek an approval, and you then once you get full scale improvement approval, you replicate the entire strategy and repeat the same steps that you have improved the entire process. Once you have a prototype ready, it doesn't take long to improve and implement this thing on overall thing, because it is the what you have improved is the subset of the same process. So yes, it doesn't take long to improve the overall process and translate. Uh, that's how it is. It is okay. Can you just give me a quick minute? Like I'll just give me one quick minute.
Go ahead, sir.
Okay. Yes. Sorry. Sorry about that. Yeah. Uh, so basically, this is how we go about implementing the like full like before and after analysis. Is there anything on the before and after analysis that probably we need more clarity on?
Sir, for the last one, in the MINITAB, we go to the assistant tab, right?
Okay. Okay. Yeah. Yeah. Let me just repeat the steps again. Okay. You go to assistant. You go to before and after capability analysis, and you go to capability comparison. You click on capability comparison. It gets you to baseline process data. Here is where you started the old Y. You select the old Y, subgroup size 1, improved process data where your new Y, and you add this new Y here to the subgroup size 1 and 425 of the whatever is the target. So in our case, it's less than like minimum 425, and we just click OK. That's it, and we
Okay.
so you
Thank you
can
so
use
much.
this. You can add in 1.5 and mention your sigma levels here. And so whatever sigma levels you got here, if you look into this, uh, you just scroll down. You had new sigma level is 0.67. So you can mention your new sigma level is 0.67 plus 1.5 here. That's where you can mention it here. You can add in the comments. That's the new sigma, new current sigma level is XYZ. Okay.
So this one is always in the default. We have to add 1.5,
Yes,
right?
yes, yes, absolutely, yes. 1.5 will be default. So for every, even the old one was minus 5.91. So you need to add 1.5 to get old sigma level. And from there, this is the transition of 6.58 sigma, which is a great deal of improvement.
Thank you.
Yeah. Any other question anyone has, but apart from this, in this list of before and after sigma levels? Anyone has any questions? Okay. So pretty much with this, we
Excuse
yes,
me.
Sanjay. Yes.
Yeah, this before and after,
Mhm.
I would like to know from you because let us say we take a decisions of, let us say there is a decision we are taking in the supermarket that within this hours we will give buy one get one free, like that, some decisions.
Okay.
And after 2 hours we are measuring our decisions whether it is effective or not.
E-
Whether this tool can be applied.
You can definitely use paired t-test version can definitely be used without any doubt. You can see whether it worked efficiently or not. You can compare say sales in general hours. Okay, let me just quickly make a small thing like there is a say probably in the morning shift morning uh, like in the morning sales data I have so what I do is like I want to check for morning uh, daily morning. So I have got like say Monday, Tuesday, every day I have like got some data for morning hours. Let me just can drag this say some days here. This is my sales data for say morning hours every day, say 10 to say 60. So some values. This is how I'm been generating these months sales, and this is post you introduce a like a campaign on offer, and this is what I get uh, for the subsequent week. I'll say this is how it shows up. Now I want to showcase, did it really work? Is it statistically significant different? This is before offer, this is after offer. Compare and see. So definitely yes, you can do that. So
Okay.
lot of such analysis, and you see basically it's all about understanding. The question here is not about that hour. It's all about now. Can I confidently say that this will work every time? That's what it is. Because every hour wise, I can compare and see did it improved or not. But given this the sample data, when you're looking at statistics, looking at p-value, and I'm looking at results, can I say this strategy will always be efficient? Yes, that's how we will be trying to do it. So yes, you should probably practice this, and this will be definitely useful. You can definitely use that.
Clear.
Okay, perfect. So it's almost probably the time for a second break, pretty much the final one, given the time zone we are in. So when we come back, we'll start with control phase and some portion of the lean part to kind of conclude the session. So like in a half an hour time, whatever time zone we are in, let's be back, and when we come back, we'll start with the control phase. Is that okay with everyone?
Okay, sir. We'll see
Perfect.
you in
Sure,
30
sure.
minutes.
Thank you.
You all
Are we back from the break?
Yes, sir. I'm here.
Okay, perfect.
I'm
So
here.
perfect. So
Yeah, me too
let's
here.
perfect. So let's get started. We like once we complete the implementation phase. Uh, Technically, my project objective is met. We've improved the overall process, but we have to ensure that the process that we have improved stays improved. It should not go back to the original state where we started from. So the control part becomes a very essential element in the entire Six Sigma journey. So control phase is where I know the process. We have got perfect strategy, perfect risk management plan. We will be setting up a control plan, which will help us ensure that the project we have improved stays improved. And with the control plan, we also have another thing that we'll be working on is lessons learned documents. So the two elements to the control phase, one is a control plan, and second is your lessons learned documents. This is like I'll just talk about lessons learned document because practically there's nothing more in it. Uh, this is something which we use for signing off the project, which we when we want to close the project saying the process has improved and now it's over. uh, You'll be the project leader, whosoever is the project leader, green belt, black belt, generally writes a small summary document about the case, the project case study sort of thing, how it happened, what went. So more like a SWOT analysis kind of thing. What were the good things about the project? What could have been done better? So basic like in journey is like summarized while you submit all the relevant documents that you might have created during the project, be it any SOP, which is standard operating procedures, trackers, templates, FMEA, any documents that you would have created will be shared with the management. This will work as a repository for the management for future projects. So whenever somebody does a future project, they can refer to these documents. A lot of these documents, templates, trackers can be used for future projects. So that's more of the like signing off document that you prepare and you share with the management. Now, the real essence of your control phase is the control plan. Now, control plan has technically three components. One is the list of action plans, the strategies that you've implemented, the last revised action plan, which got you the results, which with which you improved the entire process, now gets documented. Now, pretty much initially you were into an experimentation phase, you were revising it, you were learning from mistakes, you were updating it. Whatever was your last revised action plan will get documented eventually, will become a part of your quality manual. And similarly, the last revised risk management plan will also be part of it. That these are the things which we did to secure those action plans. So more like this is coming from the previous phase. Whatever you achieved was because of the action plans, because of the risk management plan. But with this, you also add another element, which is a new element for the control phase, is the choice of control chart. Which control chart will you be publishing? Who will be publishing those control charts? Who will be the backup? What will be the expectation from the person who is going to publish the control charts? Because tomorrow you'll be off from the project. You'll cancel the project. Like say my project is done, pretty much you will be handing over this responsibility of publishing control charts to someone in the production team, operations team who will be carrying out this job. So this person should be clear about which control chart needs to be done, uh, and like how do you need to interpret the chart and what action do you need to take. So a lot of training you have to do for the person who is going to be handling this in the control phase. The process has improved already now. When we talk about this control charts, Six Sigma happened to just copy paste this SPC charts, or we will call it as, these are also known as Sheward charts. SPC charts or statistical process control charts or just control charts. These were created in 1920s by Dr. Walter Sheward. They were in practice, they were successful, they were used everywhere. It was a proven technique, statistical process control charts. In 1986, just Six Sigma, when this board Motorola people came up with the Six Sigma thing, they just copy pasted this entire stuff and made it a control plan. This was an already existing technique or a method for analyzing, stabilizing the process performance. So pretty much you had like, so we have to only understand a which control chart do we need to publish, and like every control chart can be like different types of control charts, but practically when you want to segregate the control charts, either it will be based on the it's your data is continuous or is it discrete. So continuous data, if you have three control charts here. One is an IMR chart, which is individual and moving range chart. So individual chart talks about centering of the process. Moving range is variation. So it talks about variation. So it's a combination of two charts. It helps you understand both the centering of the process and variation of the process. We When we have a single subgroup, and I will still look at data to understand when to use which one, you use an individual chart, an IMR chart, when the subgroup size is one. Then there is an X bar R chart. X bar means mean, average, mean, and R for range chart. Mean is for centering, center of the data. Range is variation. So this is again talks about centering and variation of the data. This chart also helps you understand the process, analyze the process. When do we use it? When your subgroup size is up to 8, maximum 8 subgroups. Then you use an X bar R chart. When you have an X bar S chart, which is mean and standard deviation chart. Mean is for centering, standard deviation is for variation. When my subgroup size is greater than 8. So there are these different types of charts, but keep this in mind. This is your base chart. This is the universal chart. This is where it started from. If you understand IMR chart, you know practically every chart, not just this, even the discrete charts. Every chart will become IMR chart in the beginning. So only chart where we need to understand in detail the logic of control charts is the IMR chart. That's it. Because when you get into other charts, you'll see, okay, in the end, everything is becoming an IMR. So we just got to keep like ensure that we understand everything about this chart. Then we further automatically, everything will become very clear. So let's have a look at the data. So in the control phase folder, you have this control charts file. This is the one, control charts. The first data is for IMR chart. Let's understand when to, this is single subgroup. What do we mean by single subgroup? I'm picking up samples every hour. So I picked up a sample, measured its weight, first hour. Second hour, I again go and I pick up a sample, measured its weight. Third hour, I measured weight. Fourth hour, every hour I'm picking only one sample and I'm measuring its weight. That's single subgroup. One single column, single subgroup. Have a look at this. First hour, I go and pick up 7 samples. I measure their weights. That's my 7 subgroup. It up to 8, I will use X bar R. Second hour, again, I go pick up 7 samples. 7 samples. That's my total 7 subgroup size. If my subgroup size is more than 8, like in this case, we've got 12 samples. Every hour, I'm going picking up 12 samples. That's subgroup size of 12. So single subgroup is this. More subgroup, like depending on the samples I pick every hour, like if you can do this this is frequency, so you can pick up samples every hour, you can pick up every 2 hours, you can pick up every shift, whatever is the frequency. But I'm like based on the frequency, how many samples you're picking up. So here we're picking every hour one sample only. Here we're picking more samples. Base chart is this. So let's understand how to make this chart, interpret this chart, and then we'll take it further. So copy paste this data on MINITAB and let's have a look at this IMR chart. So I go to start, I go to control charts, and here it go down to variable charts for individuals. First is IMR chart. I click on this. I select the variable that I want to test is, which is production in kilograms. And there's some more changes I will do in this control chart. Right now, we're just looking at a simple control chart to understand the in basic interpretation. There's some more changes which we need to do, which we'll talk about later. Just click OK. That's a simple control chart. Let's understand this IMR chart first. So if I go back to my Excel sheet, this is your individual chart. This is the moving range chart. Let's understand this first. Okay, I go back here and take the average of this data. Average is 12.5625. Average of this data is 12.5625. If I go back, it says X bar 12.56. This line is my average line. average of all the data sets. Let me take my cursor here on the first data point. First data point average, value of 11, value of 11, value of 12, 14, 11, 11, 12, 14. So what it has done, it has found the average and is plotting the data around that average. That's it, nothing else. So depending on the value, the data is moving up and down depending on how much bigger or smaller is the value around that average. That's what is done. Now you have these values, which is this line, it says UCL. This is upper control limit. This line, LCL, lower control limit. So these limits are created by the data. Now, basic fundamentals we have to keep in mind. Let me go back to this annotation mark so that we can understand what is this all about. Remember the normal distribution. This is my normal distribution. That's my mean. This is mean. We have +1 standard deviation, +2 standard deviation, +3 standard deviation, -1, -2, -3. This is your mean. This is where your upper control limit is. This is where your lower control limit is. So these control limits are set at 3 standard deviation on the up, 3 standard deviation towards the low. So +3 standard deviation on the up, +3 standard. This is a vertical one, this is the horizontal one. So +1, +2, and this is +3, -1, -2, -3. That helps you understand the process. Just a chart has been tilted, that's it. So if you, when you will look at any data like this, any control chart, keep this in mind, these control limits are created from the data itself. Why? Because this is coming from the standard deviation. If the process data changes, your average will change. If average will change, your standard deviation will change. If your standard deviation changes, these control limits will also change. They are dynamic limits because they created from the data itself. So basic fundamentals, we keep this in mind. When we look at, there was something called LSL, lower specification limits. We had USL, upper specification limits. These are fixed limits. They are defined by the client. Client tells you that's my maximum limit, this is my minimum limit. Using this, we calculate the sigma level. But these are different. These are lower control limits and upper control limits. These vary as the data changes. These are dynamic limits. They calculated from the data itself. And because if your data changes, your limits will also change. These are data dependent. This is defined by the client and they are fixed. You don't change them. So when we are looking at these control charts, these are being created on its own from the control chart. Every control chart has its own unique formula. Practically, how these values are arrived, the value of control limits are calculated. Every control chart has its own unique formula, which is out of scope for at a green belt level. But these are very, very simple formulas. If you want, anyone wants, you can just Google up control limits calculation formula. You'll get like the list of like spreadsheet which tells you what's the formula. It's very simple. Put in the values as per the formula, it will calculate it. But again, MINITAB, it does on its own, so we don't need to get into that. But yes, if somebody wants to know how it's calculated, what is the formula behind it, again, it's easily available. Just type in control limit calculation formulas, you will get the list of all those formulas. Every control chart has its own way of calculation, but in general, in layman language, +3 and -3 standard deviation. That's what we should know. Now, that's the logic behind this control chart. Where is this control chart coming from? Now, that's moving range chart. Variation. This is centering, how the data is close to the center. And this is about variation of the data. How is this coming from? Let's have a look at this. Moving range. Moving range. I'm just going to type in MR. Moving range means maximum minus minimum. That's the definition of range. Moving range means difference between two consecutive value, moving values. So difference between two consecutive values, maximum and minimum, maximum and minimum, maximum and minimum. So let's find it out. There's nothing to choose, both are same. Maximum will be still same. Maximum minus minimum, difference between two consecutive values. Difference between two consecutive values. This is my moving range data, which is created in the backend. So I'll use a formula which will give me this data, ABS for absolute, this minus this, and I will take it up to here. Why? Because it covers 15 minus 12 as 3. Another parallel data is created in the backend. If I take the average, it's 2.533. Look at this. Moving range average is 2.533. First is 0, 1, then it's 2, 2, 2, then it's 4. 0, 1, 2, 2, 2, 4. Same stuff. It behaves like an individual chart. Is this clear? Like, how do we read this plots? Is that clear to everyone?
Yeah, clear.
Okay. Okay. Now I will make some changes. As I said, some changes needs to be done to understand and interpret it better. But this is just basic chart. We wanted to understand how to read this. Let me like, how does it help to have a control chart? Like, let me just quickly, just randomly, pick any number. Say, let me make this one any number. Say this is 29. Make the control chart back again. Well, that is where you will start seeing some bit of. So this data is gone out of the control limits. And I see a red and there is a number 1. So I see a spike because of that value. I see a red dot and there's number 1 value here. Test failed equal to 1. It says fourth observation in your sheet, test failed 1. The value is 29. Look at this. Moving range 17. Moving range 17. They have like gone across the limits. Now, one thing for sure, what are these limits? What are these red dots? That's what we need to understand. Now, let's understand before we. These are variations. Like the process has 2 types of variation. One is a normal process variation, which is like this. Every data can't be same. So some bit of normal plus and minus like data will be there. 11, 12, 13, 12, 13, 14, 15. Normal process. All data can't be same. This is normal process variation. But the one which we saw, this was a special cause variation, like absolutely different. So special causes can be really high or it can be really, really low. This is exceptionally different value, which needs to be checked, investigated. And that's why this is called, these red dots, when you see, these are called special cause variations. So there's special cause variations. We still need to have a basic clarity before we jump into this clarification. Keep this in mind, basic fundamentals. No special cause variation defines that there is a problem. It does not mean it's a defect. When you see a red dot like this, it does not mean it's a defect. Keep this in mind, never have the preconceived default understanding that when you see a red dot, it's a defect. No, it's not a defect. It just indicates that something new is happening in your process. Please check. There's something different, which is not your normal process behavior. I can see there is something changing. Please check. If it's good for you, please continue doing it. If it's bad for you, please fix it. I have identified something different. Please check. There's a new behavior identified. You must do a root cause analysis when you see a red dot. That means if it's a red dot, you must do a root cause analysis to see why that happened. If it's good, I must make it a practice. If it's bad, I must fix it. But special cause variation, A, it does not mean it's a defect. B, it just means that there is something different happening in your process, which is not a normal behavior of your data, and you must do a root cause analysis. That's what we need to understand with respect to special causes. But there's a one thing which can definitely come to our mind that, well, it's no brainer. I can when I'm looking at data, I can see a spot a value 11, 11, 12, 29. Obviously anyone can understand. I don't need a control chart that this is a specially high value. Everyone understands that. Yes, why do I need a control chart to tell me that it's a high value? Well, I understand and completely by that point. Special cause variations. There are 8 rules wherein only one rule talks about exceptionally high or low values. There's only one rule which says that this is special cause variation when the line, you see the lines are crossed, like you see the lines is crossed, exceptionally high value or exceptionally low value if it goes down. That will be when it's crossing the line. So it can be easily identified. You don't need a control chart to tell me that this is exceptionally high. But bottom line, this is just one rule for special cause when you can easily identify by human eyes. Again, I know there is a problem or this is something different. Bottom line, remaining 7 rules govern the data when everything looks normal. You will get these red dots even within these lines also within the control limits when data looks normal, life looks absolutely normal. This could be a problem in making, which is so small in the changes, the magnitude of change is so small that humanly it's not possible for you to track every single data and try to understand what's changing. It's not possible. And this is exception, this is something which is easily identifiable. Exceptionally high or is gone out of proportion. The 7 rules will control the data when it's within the limits, when life looks absolutely fine. There's no problem with the data. There is a problem, which is in making. And if you don't, so humanly, it's not possible for you to understand that, to track every data point and find a trend in there. So yes, control charts will go on when everything looks normal. It helps you understand that a problem has just started beginning. You just need to fix the problem very early before it really becomes a problem. It has started showing early signs of a process change. Please fix it. Please check it. So 7 rules. What are those rules? So whenever we go ahead and make a control chart, keep this in mind. These are the rules which we'll have to keep in mind. Uh, Stats, control charts. Whenever we do control chart, this is the process we need to follow. IMR, I selected the production in kg. Always go to the chart option like IMR chart, IMR options. Go to test. See, perform selected test for special causes. This is only selecting one test by default. That was, we've, there are 7 more tests which does not select by default. You have to select by default. These are standard rules. Let's understand and interpret every rule, and that's how it, you don't need to remember all this, but you should know it. There are rules. We'll change the value of k whenever we get the value of k here. 1 point more than 3 standard deviation from center line. Yes, we saw that. If any point crosses the 3rd standard deviation on the upper side or lower side, point it out as a special cause variation, the red dots. Yeah, we saw that. Any point crossing 3rd standard deviation on the upper side or lower side will be a special cause. That's one rule. Then it says 9 points in a row on the same side of center line. If 9 points are consecutively on the same side of center line, if they are consistently, let me just try to kind of put together some picture here so that we can understand what it means. This is my lower limit, upper limit, and this is my mean, average. If this is 9 points are on the same side, so data is moving 1, this is 1 point, 2 point, 3 point, 4 point, 5, 6, 7, 8, 9. When 9 consecutive points are on the upper side or one side, either upper side or lower, or probably it's on the lower side. If 9 consecutive points are found, which is not crossing this line, midline, that means the data is performing either higher than the average or it has started falling below the average. Process average is bound to change. Your process has started behaving either above average or below average. A trend, a pattern is being identified. So please check. If it's good for you, please follow it. If it's bad for you, please check it, because the process average is now going to shift and change. I can see a pattern being formed now. That's what this second rule talks about. Then it says 6 points, all increasing or decreasing. If they're consecutively 6 points, 1 here, second here, third here, fourth here, fifth here, sixth here. So they haven't crossed the limit somewhere here, but I can see a pattern. 6 points are continuously increasing, or they're just decreasing, decreasing, decreasing. That means there's a trend being formed, which will, if it continues, it will cross the boundaries. So it will show you those early signs that please check. There's enough evidence for you to see there's a trend being formed. Please check. It hasn't crossed, but if it continues, it'll cross the lines. So you have to like pick your process up from there. Then it says 14 points, alternating up and down. One day up, another down, up, down, up, down, up, down, up, down. That is too much of up and down. Well, probably somebody is fudging with the data, somebody is messing around with the process. That is too much of up and down. Please check. Similarly, it says 2 points, 2 out of 3 points, 2 out of 3 points, more than two standard deviation from center line. So what generally it means, this is might say upper limit, this is my mean, this is the lower limit. 2 out of 3 points. So this is a second standard deviation. This is my first standard deviation. So 1, 2, and the upper control limit is the third standard deviation. It says if 2 points out of 3, so 1 point is here, somewhere here, second point is somewhere here, third point is somewhere here. So out of 3 consecutive points, if 2 points are outside the second standard deviation, the data is very close to the boundaries. It's in the risky zone, very close to the boundary. Highlight that as a red dot. So that's what it says. The 3 consecutive points are there. Out of 3, the 2 are outside the second standard deviation. That means it's in the risky zone towards the crossing the limits. Similarly, it says 4 points out of 5 points are greater than 1. So if this is one standard deviation, 1 is here, say 1 is here, 2 is here, 3 is here, 4 is here, 5 is here. So 5 out of 5 consecutive values, one value is in one standard deviation, two values, remaining four are in more outside the one standard deviation. Data is forming a new average, new higher average. It's shifting. A trend is being formed because maximum data needs to be between plus and minus one standard deviation. This should be close to average. If the data is moving out, that means the process is shifting towards upper side or lower side. Bottom line, if it's moving out from one standard deviation, the process is shifting the average. There's a trend being formed. Please check. That's what it means. Then it says 15 points within one step, which is good. Within one standard deviation, we have got 15 points. Data needs to be close to the center, but that is too good to be true. Well, I'm not too optimistic about the things. Probably I'm very doubtful about this is too good to be true. The data is not even moving out of one standard deviation. Consistency of too much of consistency, I am still doubting that. It could be good, but I'm just saying, well, what's the harm in checking it? So that is too good to be true. I would like to check this. Similarly, it says 8 points in a row, more than one standard deviation. So same logic. If it's forming a new average outside the like current domain, so like if the data must go up, down, sort of thing, some bit of up and down. So it shouldn't have a linear pattern, some sort of pattern. If it forms a particular pattern, then there's a problem. There's a behavioral issue been identified. So what we need to do is we have to always go to the test, select perform all the test, click OK, click OK. See what does it has to say. When you have your control charts here, you have your control charts. It tells you 1 point. This rule failed. Third standard deviation point failed. Point crossed the third standard deviation. In the moving range, also it crossed the third standard deviation because this minus this is a big range, and this minus this is also a big range. So variation happened to cross this. If there would have been any other violation, it would have captured and given you that this rule also failed and that rule also failed. Let me just try to see if we can bring in some more change here. Let's see. I'm just randomly creating nothing. Yeah, see, the data is well within the limits. It's not crossed the boundaries, but it is saying 222, 222. That means second rule has been violated. What's my second rule? Let's have a look at it. 9 points in a row on the same side of center line. 9 points in a row. Let's have a look at point number 1, 2, 3, 4, 5, 6, 7, 8, and 9. This was the ninth one. Exclude this one. From here, this is still the ninth one. Exclude this one. From here, this is the ninth one. So I can find that the data has started forming a new low. That's how. So bottom line, what I need to do is publish the control chart and observe what's happening in my process. Whenever you see a red dot, the person who is going to be publishing the control chart must investigate, see what's happening in the process. And when you don't see a red dot, you can just mention that yes, this is the control chart for this week. This is what there's no identified special causes. We're good to go. The process is remains as it is. When you see a red dot, there must be a root cause analysis to support why that red dot had. Is it good or bad, and what actions have been taken for that. That's how we deal with the IMR chart. Is that clear to everyone?
Yes, sir. IMR.
Excuse me, just let us imagine a survey we are conducting,
Mm-hmm.
and we know the number, the range, upper range and lower range, and we got around 3-4 readings out of 100, which is exceptionally high and exceptionally low. So
Okay.
in our study, can we exclude those without going for any test and all?
So we can definitely, so this something which is exceptionally high or exceptionally low, you can definitely exclude them from your study if in case they are exceptionally high. You don't want that to kind of spoil this data. So
Yeah.
that can, so you can use the control chart here, and there's an option of brushing up. Let me see if we have this. Okay, can you take this second? Okay, let me select the data. Okay, this is data options. You can see, you can mention to include and exclude. You want to exclude certain rows, you can use this, or you can put a condition to it. Any value more than this you want to skip, or any value less than this, or any row numbers you want to mention, and it will exclude the data, making the control chart. Here
Yeah.
it is, data options. You can, if you want to exclude something, you can so specify the rows you want to include, or say I want to exclude some data values. There are certain row number I can put, I know, so say row number so and so, I can give a space, say row number 15, so the row number 10 space row number 15, 14 sort of thing, and I will exclude them from the charting options. It will exclude those data points.
Okay. Otherwise, that will contaminate total study.
Yes, absolutely. So
Okay.
that's how we go
Thank you.
about doing the control chart for IMR chart. Now, IMR chart, when we are dealing with, this is the primary chart. So again, would like to kind of reiterate, if we understand the basic fundamentals of this chart, every other chart is going to be meaningless, just meaningless, because you will see that, okay, it's everything is getting repeated and becoming a control chart in the end, which is IMR. Let's have a look at other charts also. So X bar R chart, let me just copy paste. It's just about, you have more data points to deal with. So we'll make a control chart here, control chart. This is variable chart for subgroups, X bar R, X bar R. Now my data is not in one column. This is in multiple. So I go down to drop down, and then in rows, we're looking at. So subgroup 1 till subgroup 7, all of it I need to select. So subgroup 1 till 7, select all the subgroups. Go to X bar R option as standard process. Go to test, standard process. Select all the tests because it only selects one, all the tests by default. And then click OK. That's it. Job is done. Control chart for subgroups is created. Now, just to understand this better, how we get these control charts, like what these values are? Let's go back to the Excel sheet data, and let's understand this. So first I take this is X bar R chart. If I look at this X bar R, X bar means average chart. This is the mean chart. This is range chart, mean and range chart. Let's have a look at this average. Take the average of this row, and I take average of all the rows. Eventually I take average of all those averages. See, this is a new single column which has been created. That's how it, if you look at the values, you will see 15.393. And see, this is first we took average, which is X bar, and we took averages of average, which is X double bar. If we look at this, 15.393, X double bar, average and average of average. That's what we get here, 15.393. First value 16.429. Let's have a look at this, 16.429. So it finds everything gets translated into your IMR chart kind of data because it became a single column like this one. It's happening that way, same way. There's a single column and that's been plotted here on the control chart. That's how whatever values you have here, they're plotted around this average line. For range, we don't have a direct formula. We don't have a direct formula for range. So for range, we have to get maximum and minimum from every column. So maximum, minimum, and range is maximum minus minimum. So max is max here. We pick up the maximum value from the data. We pick the minimum value from the data. And then we pick up range, which is maximum minus minimum. Let's copy the range data is ready as here. Range is here. We take the average of range. Average of range 7.93 or 94, basically 2 places of decimal. R bar 7.94. First value 8, then you've got 7, I guess 7, 888, and then you've got 9. Look at this 8, 7, 8, 8, 8, 9. Same stuff. So this is going to behave like an IMR chart again because it's formed a new single column. It will create a new single column. A single column is how it we work with. So in the end, it becomes a single column either from mean perspective or from range perspective. Is it okay with everyone? The IMR chart? Sorry, X bar R.
Yes, sir.
Okay, all right. So if we are dealing with more than 8 subgroup, then we make a X bar S chart. This is more accurate. Why? Because it's based on standard deviation. Standard deviation covers every single data point. Range covers maximum and minimum. So when your data points gets bigger, you need to go for standard deviation charts. And that's why more than 8 is X bar S chart. Having said that, before we do it, let me show you here. Assistant control charts. Here it tells you the control charts, which you know. Your data type continuous, yes. Is your data collected in subgroups? More than one group? No. Single, IMR. No, it's collected in subgroups. Then what is the subgroup size? 8 or less, up to 8 X bar R. More than 8, greater than 8 S bar S. Tells you all that stuff. So let's have a look at this chart also. Control charts for subgroups, and just below X bar R, there is X bar S chart also, mean and standard deviation chart. Same logic, one column, no, it's in my data is multiple rows. Select all the subgroups, X bar S option, go to test, perform all the tests for special causes. Same rules, standard rules. Same logic. We won't be doing this X double bar because there we took average of 7. Here we'll be taking average of 12. That's it. But let's do the other one, which is standard deviation chart. Standard deviation chart is here. So standard deviation chart will be here. That's fine. STDEV, standard deviation for this row. Then standard deviation for all the rows. And we take the average of standard deviation. Single column, everything follows the same logic. 3.214 is the standard deviation. 3.214 standard deviation. Let's have a look at this one first. Say 3.571. 3.571. So this behaves exactly like a single column charts. Everything will become eventually a IMR chart. That's how it works. So this is I hope that this should be clear. Like in case you see any variation, say what if I mess around with this data? Let me just try out. Let me hope to see some radical change. Let me see what does it do with this data. It's just one value was an exceptionally high value there. Let me just try to mess around with something more in there, just to see some more variance here and there. Okay, yeah, you got second violation again here also in standard deviation. One was first, which is more than 3 standard deviation. This is the 9 point in a row, so not from here. 1 2 3 4 5 6 7 8 9. Let's have a look at this. Tells you 1 point more than 3 standard deviation from center line. Point failed at point number 4, row number 4, which is where we messed up everything. Row number 4. is where it's talking about. In this row, everything changed. 9 points in row 4 on point number 16. Point number 16 is where the, if you talk about the standard deviation, you take up this one, it will, this is failed on the, this point, I guess. Standard deviation on number 16 here. Yeah. Sample 16 from here, from the beginning. 1, 2, 3, 4, 5, so on, 3. This is the one where it failed. 2.99, the standard deviation, take calculate the standard deviation from there, you'll see that it has failed there. So bottom line, you have to kind of always understand that if it fails any rule, you don't have to remember all those rules because it will give you, but we should know these rules exist. The most important part is like, see, you can't do this calculation looking at all the data every time. There will be something which, because the data will not always cross the limits. Those are easily identifiable, but ones which will be creating certain patterns within the data, it's imperative. And keeping in mind, this is not coming from Six Sigma. This is already existing proven technique in various industries since 1920s. This was successful. People were using it. Quality people started picking it up later. But statistically, people in mathematical background, people used it in agriculture, people used it in chemical industries. And because you need to make sure, because it's so volatile, data is changing dynamically. So you need to have some sort of monitoring mechanism so that it doesn't fail and it doesn't go out of proportion. If you keep assessing your control charts, will never go wrong, because no process will become good or bad overnight. It will always have some early signs which humanly it's not possible for us to track. Rules will not miss out them. So just have control charts in place and keep monitoring them. Coming to the other set of control charts which we have for discrete data, we have 4 control charts, and they are single chart. They're not combination here. Discrete charts will be either C chart, U chart, P and NP chart. So it's based on the logic of defect and defective. So either you'll end up making a defect charts which for defects, or you'll be making a chart for defective. But for that, we need to understand the basic difference between defect and defective. So we've taken a simple example of a marker manufacturing firm, which is auditing its marker on the basis of 4 different parameters. They'll check the marker, whiteboard marker. Is this cap fitting in fine or not? Is there a leakage in the marker? Are they printing mistakes in the marker or not? Are the colors? Is it like black marker writing black or it's writing blue? So basically 4 different parameters are there, and they audit all the markers basis that. So they found like they did this audit. Now, if I want to calculate the defect, I have 3 defects. The one and the third marker, which is leakage problem, and the 5th marker, I had a printing mistake and color problem also. So I had 3 defects. When I talk about defective markers, I have only 2 defective. One is marker 3 and marker 5. They're 2 defective markers, but they're total 3 defects. So either you are working on defect, you're trying to reduce the defect, or are you trying to reduce the defective units? So this is for count of errors. So if you want to kind of, this is count of errors, this is count of defective items. Which one should be choosing? You don't decide that. Your organization culture will decide that. People who work on defective model, companies who work on defective models are very brand conscious. Like an iPhone, they work on defective model. I'm not saying the companies who work on defect model, they're bad. Absolutely not. Depends on what kind of culture organization culture we have, and what kind of clients do you cater to. Let me give you a simple example so we can understand. Like, so I can't name the organization there, but yes, we were auditing for one of like a cell phone manufacturer, like a Chinese brand cell phone manufacturer, which is based out of India. And there they found that last night they manufactured some phones, and all the phones were heating up too much. Uh, and it was caught by the quality team the very next day when they were auditing it. They marked the defect. They sent out communication to the production floor that all the phones that you manufactured last night, they're heating up too much. They figured out what was the reason. There is a cooling paste which is applied on the electronic parts, because when you use the phone, it will get heated up, and electronic parts will can get destroyed because of that heating. And plus, more like customers will have a complaint that this phone is like very hot when they use it. So the people in the night shift, they forgot to apply the cooling paste on the last night production. That's how when they manufacture, they need to apply the paste there, which they forgot. My understanding was that those phones will be repaired and they will be fixed and then they will be sold. But no, those phones were sold out in the market. They were sent for to be shipped to like various stores and everything. And the simple question, simple answer, justification was that we don't work with huge budget like iPhone does. We're dealing with budget size phones, and with this kind of money, we should be okay with this kind of little problems here and there. It's a working phone, yes. It's a functional phone, yes. Does it have a heating issue? Yes. If the customer complains, yes. We have 1 year of warranty. The customer can go to near service station, service center, and get it repaired for free. Well, that's done. You have got to be ready to take this much of pain. This we can't just scrap it because we had a heating issue. It's a functional phone, although, yeah, but because again they don't have actually they do generally don't work with that kind of budget, so it's that doesn't mean that love defect. They would like definitely like to correct it, so they will make a note of the defects, count of errors. So they would like to check the process about the count of errors they're making, and they would like to fix and like keep the process under control. They will be making control charts from this defect section, when they're concerned with the number of errors. But companies like iPhone, they see a single defect. Unless until that's fixed, that item can't be sold. Like these Rolex watches, they are absolutely like very customer centric. They don't even rework. I think they just like what I've heard. They just scrap off that watch if there's a defect in this. They don't even rework on it. So defective model. So they are very brand conscious. There are no percentages for quality. Either the product is 0% or 100%. There's nothing in it. So they don't have percentage defective. No, there's either the product is good or bad. There's nothing in between. So companies which are very brand conscious, they will always work with a defective model. So again, nothing right or wrong. It's just about the kind of clients we're working with and the company psyche. We have to use the model, the chart. Now, either you'll be then making a C chart or a U chart, or you'll be making an NP chart or P chart. That's what. Now, whether which one would you be making, C or U, will depend on, are you picking up same number of samples every day for auditing, or are you picking different samples, variable samples. Similarly, the NP. Let's have a look at the data. We'll understand it better. C chart. I I pick up 10 samples every day, 10 samples, and I count how many defects did I find. Fixed samples, and I'm counting the number of defects, every day. I'm picking 10 samples, fixed number, be it 10 or 20, but whatever is there, I pick fixed number of samples. I'm counting the number of errors or defects I find in them. So I am making a C chart, fixed samples, counting defects, C chart. Have a look at the other one. Someday I pick more samples, someday I pick less samples. My sample size changes, variable samples. And I'm still counting the number of defects I find in them. Every sample, how many defects did I find in them? Variable samples, yes. And I'm counting the number of defects, number of errors. Yes, that's what we have. For U chart, data will be like this. Coming to P chart, here we are finding defective samples. Defective samples, but my sample size is variable, it's changing. Someday I pick more 11 samples, 20 samples, 23 different samples, and I see how many defective samples do I have. Like out of 11, we had 9 defective samples. That means there were either 9 items which had at least one defect. So that's how it is. Only 2 items which were defect free. So that's how it is. 20 items, only 11 items were defect free. 9 had at least one problem in it. So defect or defective. So NP chart will have fixed number of samples or for auditing, and I'm calculating the defectives, like how many defectives do we get. So let's have a look at the C chart. Here rules are same, but we have only 4 rules. The first 4 rules remaining are not applicable in this chart. So this is for the data for C chart. Yes, Sanjay, you have a question?
This samples, this is sample size. Actually, defects cannot be more than the sample row.
Defects can be more than the sample. Defectives cannot be more than the sample. Thanks, you kind of pointed that out. Defects can be more than sample. So if you had 5, okay, let me just make it. Oops, I opened a new sheet. Okay. Now, how many defects do I have? One, two, three, four, five, six, and seven. I have seven defects. How many samples I have? Only five. I have
Clear.
marked. Okay. But defective, out of five, I can have maximum five defectives only. So,
Yeah, yeah.
yeah. So that's how we, going back to the C chart. Now, I have my samples here, and I want to see whether this is under control or not. I go to see stat control charts. All these defect charts are in attribute charts. All these C, U, P, and P. Let's go to C chart, which is at the bottom, and U is right here. P is here and P is here. So let's pick C chart first. What do we want to measure? The defects. C chart options. Test. Only one is selected by default. Select all four here. Okay and okay. Is doing nothing, the same. Taking the average and plotting the average and the number of defects around that average. That's it. No other logic. Same law of logic of IMR chart. Those rules are applicable. If there's any violation, it will be highlighted.
So, Mr. Sufi, why it called C chart?
This honestly, there's no justification and there's no expanded version for that. Also, these are like C, U, P, and NP. There is no expanded version. These are not abbreviations. They have been known like this, and simply I don't have any
Because
reasoning for
many
that.
charts it look like a same with the different name. So how we can understand?
No, so you will be making, see, these are the name of the chart which is like globally known, depending on what is your need. So see, C chart is, so you have to have this table in mind. Look, so this is this simple table. This is the table basis which we will be picking up which chart we'll be making. Depending on the sample, these are fixed names, so they are not like, the charts would look different also. When you look at other charts, when you look at the control chart, you would not be, this is telling you how many samples, like how many, this is always going to come with the, because you're choosing a C chart. Why? Because your fixed sample size is there and you have count of samples, sample count you have here. So how many defective samples you had, defects, like out of those total number of samples, your fixed sample size, like what is the average of the number of defects. Say if you want to find out here, go to the Excel sheet. What it has done is taken the average of those samples.
You know, it's
20
clear.
point.
There is no doubt on the calculation. Just only the doubt of the naming. Like the same chart we are pronouncing on the different.
The chart is like the fundamentals of the charts are different, because one will be calculating the defects, one will be calculating the defectives, and moreover, when you look at other charts, the looks are also going to change. Now the next chart which we'll be looking at will be very different from what you have seen. Like, let's have a look at this one. This is the U chart data, and have a look at this. It will, and the next question definitely is for everyone, like to have a look at this. What is different in the control chart and why is that different? So this is U chart. I put my defects here. Subgroup size is my sample size. U chart options, test for all the causes, and click OK and OK. Now the question is, what is different in this control chart and why is that different? What different do you see in the control chart other than whatever control charts have you seen so far? What is different in this one?
UCL and LCL varies. The
Thank
value.
you. Thank you, Elizabeth. You're right. Absolutely correct. So in every other control chart, we saw flat lines. Control limits were flat. Here you see zigzag control limits, and this is not the final one. This is for the last one. If you take your cursor here, it says 0.636. If you take your cursor here, it's 0.686. You take a cursor here, 0.895. Keep this in mind. That's what we discussed in the beginning. Control charts are a property of the data. As the data changes, sample control limits will also change, will vary. This chart is a dynamic chart. Your sample size is changing every time. It says tests are performed with unequal sample sizes. Because your sample size is changing, your control limits are automatically adjusting as per the sample size. So for every sample size that you picked up, it's defining its control limits. And your data is changing, so would your control limit change. And according to the sample and the data, the defects you found, it is creating a control limit and then checking whether it's good or bad. This is preferred chart. Practically, it's a very dynamic chart. It helps you understand the process behavior. Even when your process has too much of variation, you can use this control chart. It helps you understand bottom line as per the sample, what would have been the right limits. It automatically creates them. So this is the basic reasoning behind the control chart. Again, help me understand, is this good or bad?
Bad.
Again, just think about it. What are you measuring here? These are, this was expected to be having a maximum of 0.895. You've gone out of proportion here, 2.06, which is bad. Defects higher. You would expect to have these many defects. You've gone really, really high. This one is exceptionally good. We were expecting at least defect of 0.19, where you delivered is 0.16. I would love to know how did you manage this? Special cost, low, lesser the better. The defects, lesser the better. Defects, this is bad. Upper control limit, that means your defects are very high. This is good, very good. I would love to know how did you manage to do this. And I will be very concerned about these. They are bad. These are bad. This is good. Absolutely good. I would like to do a root cause analysis for this and
Yeah,
all
got it.
this.
Yeah, yeah.
Okay. Let's have a look at the P chart, which is again going to show a zigzag, but this is percentage based like this, right? Want to, so another data, single column data, how it's going to be formed. 9 divided by 9 defective out of 11. This is the data being created in the backend. Have a look at this. Let me just put together this form value and let's have a look at this. This is P chart, attribute, P chart, put in the defectives, subgroup sizes, sample size, P chart options, test for all the causes, okay, and then okay. See, percentage of defectives, and look, let's look at this, 0.8182. This is all here, 0.45, 0.45. This is percentage defectives for the for this one. Again, for similarly, you have the other one, which is NP chart. Here you'll be back to the flat lines because sample size is restored, sample size is fixed. So we don't have anything else to kind of look into it. Like simple standard rules, effectives is what we are analyzing. Sample size is fixed here. No more changes. So pretty much won't have a problem there. All the rules, that's it. You have your, these are good, exceptionally good. I would love to repeat this. Lesser the better. I will be concerned this is not crossed, but I'm very concerned about this. How did we go that high? Bottom line. But yes, I just got to keep this basic fundamentals in mind. What's going wrong? What is going on?
Mr. Sophie, then why we would needed the lower control limit? Na? It is not required because I don't want to control in the lower side.
No, so it's see, I would like when it creates, because it calculates the formula, this helps me understand that we have done something phenomenal. Looking at the data, there was some bit of defects were expected. It does not mean that when like have the basis the data, it is going to form a control limit. It's saying that we were basis the data, we were expecting at least this much of defects, but you've gone much below that. That means you have started doing something which is very good, and you need to understand how what did you do. So
But
for
my
me, that's a
expectation is always zero. Na? Why I will expect I would have the defect
no,
in my.
no. This is not about expectation. This is about the process data is bound to create at least this much. The standard deviation. It is set at certain standard deviation. So my process basis, my historical process data, it's telling you that at least this much of defect will happen. It's not my expectation. This is the process data which is telling you, basis the historical data that we have analyzed, these many defects will happen or bound to happen. What we did is different from that. It's not that we must have these many defects. No, these are else. This is lower control limit of the process, that the process data says that you can have maximum of 10 defects. The likelihood of you getting defects is maximum up to 10 and lower up to 1.18. This is process behavior is telling you this. But what you have done is different from the process behavior on these three occasions, which is good. It's not that expectation. The expectation is LSL and USL. What you are mixing it up with LSL and USL. Definitely, I will not have a LSL for defects. I will might have a USL for a defect. But these are control limits. They are created from the data. LSL or USL will have only one. So, okay, let's understand this way. Mm, okay, let me just get a simple control chart here. So that way we will be able to plot IM on this one. Production in kilograms. Let me just get this one so that we have a clear understanding about this. Okay, stats, control charts, say individual charts in IMR. Production in kilograms, IMR chart, and test all the causes. Okay, now, would you like to have um a minimum, like a minimum production limit or maximum production limit?
Always minimum.
Minimum, yeah. So below that, it will be very, very bad. So I'll say probably my average production is about 12.64. Uh, I want a minimum production to be done, which is at least, say, 9 kilograms. Currently, our average is 12.64. So I can do a right click here in the chart, add items, reference line, and I will go and put in 9. That's it. Let's see, what is it? This is 9, which is my, let's understand and interpret. This is defined. This one is defined by the client. The client will say that I need a minimum production, which is 9 kilograms per day. Now, what it tells you, look at this and try to understand. The client has given you a requirement that I must have minimum of 9 kilograms production every day. But what it tells you that on an average, your process is giving you 12.64 kgs of production, but there is a likelihood that you can go and exceed production up to 20 on the upper side, and your process has even a tendency to go up to 5.28 kilograms per day. When it crosses this limit, so yes, there is a likelihood that you will not meet client expectation on certain days, because your process has +1, +2, +3 standard deviation. So some data will fall here also someday. So your chances of crossing this limit are there. So you have a problem. This process is not good, because you have a likelihood that your process, because it tells you that +-3 standard deviation tells you that your process has a capability of moving 1, 2, and 3 standard deviation towards the up. Similarly, the process has a chance of moving 1, 2, and 3 down also. So you have a process has a likelihood of going below this, and there's a good scope here. So this is bad. Is it? I hope that's clear.
Yeah, clear.
Okay. Similarly, let's say uh, let me just create another. Assume that is not a production data. This is time related data. Just assume this is a time related product, time related data we have got, and the client has given us a threshold that uh, we should be able to deliver the products what we manufacturing for the client maximum by 22 days. 22 days is my target. I'll go to my reference line, put in 22 here. It's 22, and I click OK. This is 22 days. I'll just add this here. 22 days USL upper limit. Client has said you should be able to deliver everything by 22 days. Well, that's what I understand. Is this process good or bad?
Yes, good.
Very good, right?
Yeah.
Oh, perfect. So, absolutely good. Yes. There's no way. There's no way. I'm like practically 99.7% of my process will be completed by 20.0 days, 01 days. So this is very good process. I'm like my on an average we're taking about 12.6. There is a chance we can even take less up to 5.28 also, which is very good. Client has given me 22 days limit, and even if my maximum goes till 20.01, that's great. That's like this is a good process. So you can define these limits because these are defined by the client. This is changing. This will keep on changing. If your data changes, these limits will keep on changing. So you can add your client limits like by right click this way. Reference line, put in your target, whatever the client says. That's where you will be able to see how you good, this is how your process is performing with respect to the client expectation. I hope everyone is okay with this control
Yes,
charts.
sir.
Okay,
Yeah, okay.
perfect. Okay, perfect. So with having said that, the control charts, we're done with the control charts. Uh, the last thing which we are left with is the basics of lean part of it that we have to kind of look into. So from lean basics perspective, whenever we talk about implementation of lean, so where do we implement the lean part? When do we get started? We actually start when we start the improve phase. So when we have this improve phase, when the team is getting into the regression calculation and you're dealing with the process experts and all that stuff, parallelly I can have some of my people start the lean initiatives. Now they're parallel. They will never interfere with each other. So I can start with my ideally you want to start it early, you can start it early also. There's no such rule. Whenever we talk about implementation of rule, first thing first, we should always keep this in mind. 5S, which is original version is 5S. Now we have got extra S added to it, which is 6th S. So this is my minimum requirement. When I'm going to start my lean initiative, I must have my process controlled in terms of 5S should be implemented and adhered. People should be clear about it because you need to condition the mind of the people who are going to be part of the lean initiative drive. Lean is minimum office basic hygiene requirement which must be adhered. So original 5S is what we will first talk about, and the 6S we have just added additionally here. Now 5S, well, the first S is all about sorting the things. Now when we talk about 5S, let me just quickly show it to you, like so that we can have a quick idea about this one. Team basics. The first S, it starts with sorting. So sorting is all about uh, keeping things which you need for your daily stuff, like so whatever you need on a day-to-day job, whatever is required, only the required stuff you need to keep it. Rest everything you need to just discard. Simply it's an act of getting rid of junk, anything which you've not been using, material, files. So people working in a factory kind of thing, you see some junk stuff like even some material which is just lying there. We have never been using it, but it's just packed there. It's occupying some space. People who work in laptops and all that, we have so many files which we never ever going to use. uh, you see someone's desktop, it's like there's not even a single space to put another file. It's all packed up. We have no clue what's lying where. That's where we need to do this first test, is to get rid of anything. And the simple rule says, when in doubt, just remove it. Simply, if there is a really essential file that you need, if I ask you a question, do I need to remove it? No, you will say, no, I need it. This is very, very, very important. So you know for sure this is very important. Rest, everything needs to, the moment you have a slightest doubt that whether I should keep it or not, that means is you better off get rid of it. In a factory kind of environment, like you usually they create a red tagging area, they mark area, with a showing that this is a red tagged area where you chunk all that material and physical products there, where you keep that unwanted stuff which will be used by people who need it. So one area everyone puts the discard stuff, and you only keep what is required by you to do your daily job. That's how the sorting part happens. Sorting is all about keeping the things which you need to do your job without any obstruction. Then comes set in order. Set in order basically goes with a simple tagline. Everything has a place and everything in its place. So there's a designated space for everything, and everything needs to be kept in that place. That's how it is. You need to keep things in the right order in which you need them to be accessed. Like something which you need every hour should be near you. You shouldn't be running in 10 different directions to get your required stuff. What you need every hour, hourly basis. Say probably you need it every day. That should be easily accessible. Probably something which you need in once in a week can be kept at a distance. So the the way you need things to be accessed, that should be the proximity of the thing should be kept like it should be kept in mind. The things which I need in an office kind of laptop, which I need frequently, can be on my desktop. Something which I don't need frequently, that shouldn't be on my desktop. Simple as that. That should be somewhere in the folder, in a proper designated folder. But the ones I need frequently should be there. Without it, I should be able to access them effortlessly, instantly, and that's how it is. Set in order. Keep the things in an order in which you need them to be accessed. That's the set in order. Coming to shine. Now, shine is sort of a self-explanatory thing on its own. Again, cleaning is hygiene is not a debatable topic, but yes, still in a factory kind of environment, you say there's a gen set which has got leakage in it, and you don't keep it clean, it can cause fire, it can cause accidents. But if it's clean, even a single droplet of oil, you will see, well, there's a leakage happening. And like or IT kind of environment, dust that can cause damage to the laptop servers and everything. So keeping it clean is it's a self-explanatory thing. You must keep it clean because there's no advantages of being unhygienic, but there are tons of disadvantages of being unhygienic. Most companies, most people do follow this first three. Again, if they follow this, they do it, but yes, not frequently, but on an ad hoc basis. Yeah, generally wherever there's a culture of 5S, who have at least practiced 5S once, would be maintaining the first 3 years. And I'm talking basis of the experience. uh, Most people do maintain this on an ad hoc basis. Some companies also in more, but I would say some companies even up to the standard of 4th, they can get up to this level of being compliant, but not on regular basis. This is generally done like people do it, forget it. This is daily job. You got now when you talk about standardized, it's all about color coding, labeling, like an Excel, like you have Excel sheet name. There should be file nomenclature. When you have folder, you have a folder nomenclature. It bottom line, when we are talking about standardized, like you go to hospitals, you see the different color bins. You know by looks of the color of the bin, you know what color bin is for what, which purpose. So there's no confusion when you look. When you go to library, you're able to spot which medicine is supposed to be where. So there's certain color code like which book, when you go to library, there's certain labeling which is done. Labeling and color coding, this is more of standardization part, so that just by looks of certain things you can understand what needs to be, where it needs to be, and practically there will be no more confusion. So if I want to just show you, this is what I'm talking about. This is before 5S. So everything in its place and everything has a designated space. So it can't just move around anywhere. Color coding. You can't take yellow and put it here. Can't take blue and put it there. Bottom line, that's how it is. Then you have got designated, nothing unwanted stuff is kept here. Everything what you need and the way you need to be accessed are the ones which you need to access easily are kept in the lower racks. Something which you don't need frequently can be kept at like a little higher rack. So you don't have to kind of jump around to get it. Simple. It is basically commonsensical stuff, but trust, because you do it every now and then. Now most people find it like very stupid. Like it's not big. Like unless until something is very technical and complex, we don't find luxury like enjoy. We don't enjoy that. It's like a very simple thing. Unfortunately, those simple things are not being adhered, and most of the answers are always in the simple things rather than the complex ones. So that's how I basic like I look at this someone's desktop where like it's like table which is kind of all filled in with unwanted stuff. Probably I wanted this only, but yes, I mean there are a lot of stuff which we've seen while auditing and implementing 5S in various companies, and things are bizarre like this. Definitely, I would say it like piled up like this, but yes, they're bad in a bad shape. this kind of environment is also visible when you, I'm sure you might want to try out and see and analyze things from that perspective. You'll see such things are, we are not planned to do all these things, and we are not conditioned to do all these things. Japanese people were I would say they mastered the art of lean, and trust, everything starts here in the 5S. Here is where your role or our role comes into picture when you talk about sustain. Everyone can do these things because these are simple things, but because they're simple, it never gets to our attention. We don't do it diligently every day. For some days we might do it, then we will start forgetting, oh well, I know this. Overconfidence comes into picture. Probably like it's so simple that it never gets attention. Probably we get tired of, we try to kind of sacrifice this at cost of something more important. So this may not become an important element, and that's why it keeps getting ignored and neglected, and it becomes a practice. So sustenance is where the biggest challenge comes into picture, and that's where the role of management comes into picture. You need to, as management, drive this behavior. You need to promote people, educate people, reward people, do everything possible to make it a culture, because this is going to be the beginning of, because people, for lean, you need people who are open to change. For lean, you need people who are who understand the culture of like doing something, the act of the belief of making a change, bringing out a change. So for that, you need to you're conditioning the mind of people by implementing these 5S. So we should ensure that should be some daily huddles where we make it a talk of, like everyone talks about it. Post shift huddles, we should talk about it. So appraisal meetings, we talk about it. This should be made a big deal, and that's the role lies with the management. You need to make sure there is a proper rewards, recognition done on this. People are appreciated for going to do a good job. People who don't do it are pulled up for not adhering to it. It must be, it's a basic stuff which needs to be implemented. Otherwise lean can't be done. Simple as that. I would just would can't be made as simple as that. This is you where you're trying to condition the mind, and it's very difficult to change someone's perception of behavior or habit. So you're trying to kind of just get the basic ingredients in place before you launch your lean initiative in future. You need to prepare people who are receptive to change, who understands that now, yes, they have a role to play in this organization. You can't work with people who have like closed their minds and who don't want to change, or probably they're not aware that they can be a great contributor or to the organization or to themselves also. So it's all about conditioning. I would say conditioning the mind. The latest entrance in this intent is this safety measure. So all those risk management part of come into safety. Say a lot of job hazards, health hazards are associated with a thing in IT world. Is this IT data theft, which are, so all those safety protocols will be followed, will be added to this safety measures. This safety committee or steering committees are created in this, and they will look into all those safety related measures, so not just health safety, like safety from every perspective. What can go wrong? The FMEA culture will also can also step in. So all those safety measures, it's not a small, like it basically it's a holistic approach of measuring what can go wrong in the business, in the process, from business standpoint, people standpoint, health, every possible perspective. Safety is a big broad topic which was eventually been added by Americans, but original version is 5S. It's been recently, like not, I would still say recently, it's almost been a decade people have been using safety as a sixth S. Is there any questions on the 5S culture, like 5S thing? Anyone has questions? Any questions on 5S? Like what do we mean by these?
On my side.
Okay. Okay. All right. So now, say once we're done with the basic 5S implementation and all, uh, you need to get started with the lean initiatives also. So lean is all about identifying and elimination of waste without compromising the quality. So your process starts at A and ends at F. Every stage uses some resources in terms of people, time, money, everything, efforts. Every step adds some cost. So when this process happens, your customer gets some product. So the customer say gets some product or service is being delivered to the customer here. So say this is taking me say 15 days time for me to deliver this product or service. Now I want to cut down this time. Lean is all about time. Can you deliver it faster? That's what we deal with in lean. But we don't want to compromise on the quality of the product or quality of the service. So first we do is we identify the waste. Where is the waste in the process? What can I cut off from this process? Keep this in mind. This is basic fundamental. Lean, every answer will be done from customer standpoint. Every question, wherever there'll be question or disconnect, confusion, always ask this question from the customer standpoint. What would customer like? Not what would I like, not what is profitable, not what my stakeholders would like to see. No, it's everything. What would the customer be looking for at this stage? If you're given a chance, you be the customer, what would you decide? That's how it's answered. So say we're talking about step number A. I want to understand, is it a waste or not? If I identify that is a waste, then I would definitely want to remove it. But how do I identify? The first question is, will the customer be willing to pay for this activity? Say this step number A, we tell the customer that, yeah, we are doing this step number A, we are utilizing some resources and everything. Will you be ready to pay for this? If the customer will, if we ask this question, if we get an answer, yes, we will, I'm ready to pay for this. If it's meaningful for the customer will be ready to pay. If this activity is important for the customer will be ready to pay. In nutshell, say for example, you get somebody from a Harvard or some from Oxford University to do the job. You hired like an MBA from some of the like prestigious university. You hired somebody at a really really high pay scale, and obviously because to compensate for that cost, you had to increase the prices. The price of the product is high and all that. You tell the customer, well, and we have got somebody which is a Oxford educated person, like, and now this is going to streamline everything. Uh, that's why the prices have been increased for the product. Why would the customer be paying for your Wilson fancies because you wanted to hire somebody from some Oxford University? Well, that's meaningless for me. Why would I pay for your like your probably you want to upgrade your machines? You have some machines and want to upgrade the machine. Where would the cost come from the product? Obviously then the product cost will increase. Why would the customer pay for your machines? I'm going to be paying for your product or service. Why should I pay for your product or machines you want to upgrade? So bottom line, for every question you're going to be asking, like, is will the customer, we tell the customer that we are doing this step, these are the activities, will the customer be willing to pay for that? If the answer is yes, then it's a meaningful activity for the customer, and customer wants that to be done. It's important. It's a value-added activity. You can't remove it. If the answer is no, the customer says no. Well, why should I pay for this? It's a bit like I don't want. Why should I pay for this Oxford guy? Well, bottom line, I don't want that. No. Then you have to ask this next question. If you remove this step because customer doesn't want it, will your product or service fail? If you remove this step, number A, will you eventually this process will fail? Will the product quality get hampered? Will the service quality get hampered? If the answer is yes, then no, you can't remove it. It's a very important step because this step is doing something with the product or service. If you remove it, your process will fail, your product will fail. It's a value added activity. You can't remove it. It's an important thing because this step is transforming your product. This step is transforming your service. You can't remove it. Otherwise, your product will not be delivered, your services will not be delivered. It's a value added one. You must keep it. If your answer comes as no, now you got to ask a question of yourself. Neither the customer wants to pay for this activity, nor if you remove this step, still doesn't matter. Your product probably it's taking lesser time now, 10 days, and my product quality still remains the same. And tell me in the first place, why were you doing this step number A? If now it is, if when I remove step number A, I'm just doing B, C, D, E, F, and it takes me 10 days. And product quality is still the same, or probably better. Then ask me, tell me a simple answer like, why were you doing that? Neither client wanted, neither customer wanted it, nor it's impacting your process. Why were you doing it? So simple as that. That's a waste. Neither the client wants it, nor it is impacting your process, product, or services. That's a waste. Can you remove all the waste? The answer is no. You cannot remove all the waste. The waste will further be categorized into two types: essential non-value added waste. This is not as waste is basically non-value added. It's not adding any value to the process or to the product. It's non-value added. Value adding is what customer cares about, which is doing something with the product. This is a value added. This is non-value added. But these are essential waste. These waste, like having an HR team, you can't have like people without having an HR team. You must have them. Who's going to recruit right candidates? Quality team. Well, are they making a product? No. Why would the customer be really should be paying for your quality team? You hired them. Well, a customer wants to pay for your product or service, not for your quality team, but the customer pays for it because ultimately salaries have to be paid. That will be added to the cost of the product or service. Will Are they doing anything with your product or service? No, they're not doing anything. Having the training team, are these doing anything with the product? No, they're just training people. Our finance team, they are not doing these people are not. Now if you tell the customer that you are paying for all these people and their cost is being salary and everything is being paid because on as added to the product or service that you're paying for, well, the customer will never be happy about that. And moreover, they are not a part of your regular process A, B, C, D, E that neither manufacturing this product or not the services. They are working parallelly. These will be support lifeline for the process to work fine. You must have them. Otherwise, your process will fail indirectly. Not directly, but indirectly, the process will fail. But something which is not even essential, that's a pure waste. You must get rid of all this waste. This can't be like you just need to get rid of them. So it's been categorized as like 8 types of waste. Originally, we just had 7 types of waste. Americans again added the eighth one, which is skills. So Tim Woods is the easy way to remember this. T stands for transportation, I for inventory, M for motion, W for waiting, overproduction, overprocessing, defects and reworks. Skills, when I say it's unutilized skills. So, what is this transportation waste? It is basically the movement of material or things. So, when you're moving material from one place to another, from say production from store to production house, production floor from production floor to some other place, whether you kind of shifting this stuff here and there, it is utilizing some of your raw materials, some of your resources, say some cranes are required or whatever equipments, machinery you're using for shifting the product. You're utilizing some resources, people to move that product. Finished goods from production floor to the to back to the store where you're gonna keep them. All those movement, there will be some required movement, definitely yes. But there are a lot of times when you see the product is being like moved from one place to another. If we talk about an like in an office kind of environment, files are moved from one desk to another. That movement is adding no value. That's a waste of time and money for everyone. Practically, this movement is adding of no value because it's not transforming the product. It's not doing anything with the product or service that you deliver. And this excess movement is consuming some resources which needs to be cut down. Transportation waste is movement of material or thing. Inventory, it's the mother of waste. It's raw material. You probably anticipated there will be a requirement or demand in future, so you purchase a lot of inventory, raw material, assuming there will be demand, and I'll start manufacturing it. A businessman money is the money in circulation which keeps rotating. The moment you blocked the money as inventory, now that money is stuck. You have to, in it doesn't end here because you have to keep it somewhere. There'll be cost of keeping it, there'll be cost of managing it. You want to secure it, so in so insurance cost and everything, you have to have somebody look after that inventory also. There'll be cost of this management also. So it doesn't end there. It's too like you kind of invited like you kind of blocked a lot of inventory, so waiting for the demand. Now what if the demand doesn't come the way you expected it? Your money is blocked. So you need to look into the inventory management and see, are you blocking too much inventory, because that's a waste, pure waste there. Motion is very common in corporate, so corporate world, it's very common, motion waste, because it's so small that people don't even look into it. But I'll just give you a very simple example. So we say we had a huge facility, like where I was engaged with the corporate sector. I'll sort of very briefly, I'll give you a small idea about what this motion waste, how big is this. So this was like a huge facility that we had, and we had a huge centralized printer that we got from US and for the entire organization. This is where somewhere my cabin was, and this is somewhere that huge printer was there, and there was this sort of for everyone centralized printer, and there were a lot of cubicles, and I had to walk from the corridor. So if I give a printout, I have to walk from the corridor somewhere like this and reach here. It used to take good 3-4 minutes for me to reach there, pick up my printout, go back, do this marathon 3-4 times in a day. And this is just, I'm talking about one activity of like printouts. Similarly, there could be other activities, but if I do a basic maths, it takes me say roughly 3 minutes to go to the printer and come back. It takes me 3 more minutes, 6 minutes wasted in picking up a printout. So I similarly I do say give 3 printouts in a day. So I do this small marathon miles for myself. I waste 18 minutes in a day doing this back and forth. 3 minutes, nobody bothers. Just walking the corridor doesn't matter. 18 minutes wasted in a day. So you work 26 days in a month. We work 12 months in a year. These many minutes I wasted in a year walking in the corridor, picking up a printout, just one activity. And for myself, there are a lot of people doing the same in the organization. Divided by, you got converted to hours, divided by 60. I wasted 93 hours in the corridor picking up the printout and convert into number of working hours, working days. 11.7 days of salary wasted in a year just picking up a printout. And everyone is doing the same. And there are more such activities. Is this walking in the corridor helping me with any product manufacturing, services, delivery? No, that's waste. And this much of money, I had to look at my salary and understand this is just one activity. Nobody does this maths. And because they're so small, 3 minutes, nobody cares. When you don't do this maths, you see so many activities are there which we do, which are motion waste. This is a big curse because the magnitude is small, but we never do this mathematics. It will get clear. Waiting is a pure waste. When we talk about waiting, waiting is we're waiting for instructions, we're waiting for raw material, waiting for anything. Lean is about cutting down time. Can you deliver it faster? And why are you waiting? If my step A completed, B hasn't started, why? What are you waiting for? Whenever you see a waiting and the steps ends, other doesn't start, we need to understand why there is a wait. What are you waiting for? And we need to kill all that elements. Why are we waiting for? Is it instructions, approvals, raw materials? What is there is the reason why you're waiting? Waiting needs to be removed because that's a violation of lean. Lean is all about cutting down the time. You kind of increasing the time. Overproduction. Well, thanks to your inventory, excess inventory. Earlier it was raw material, now it's finished good. Now you're waiting for the production raw finished goods to be sold when there will be demand in the market. You kind of stocked up your stores unnecessarily, still waiting. So this is these two are interlinked. You when you have excess inventory, you end up doing excess production also. Over processing again. This is also one of the curse that people have. Like I would say, people have this habit of over processing ourselves. Say the client has given us a, I'm talking about in a manufacturing kind of environment. Say a client has given us a requirement that we are okay to get a product which is, say, 2 mm long till say 5 mm long. That's basic requirement. Now, the client is okay with this range. What my probably my boss will come back and say, no, I want you all to work the between 3 and 3.5 mm. We want to be very stringent. Well, I completely understand. This is where you want to streamline your process, be very accurate. But you are over processing it because you are making things very difficult. Anything less than 3 mm, you're saying it's a defect. Anything more than 3 point, you want to create like set up more control, stringent methods of controlling it. You because you want you're like concerned about not hitting this less than 2 mm, not going beyond 5 mm. So you made it very stringent process, internal process. You're over processing it. I understand you have a reason, but by putting such narrow, tight range, which is not even expected by the management, by the client, you are making it difficult. And probably to maintain this, we might have to end up investing a lot of money. That's an overprocessing. Client never asked for it. something which my client has not asked for it, if I start delivering, trying to deliver that, I may be kind of spoiling my, like I might be making things difficult for myself to probably please the client. I want to be, well, there is a range, there is some limits. It's good to be consistent, yes, but we'd like to not like it to suffocate ourselves to maintain that by raising the bar to that level where it's not even expected, like not even expected to deliver that kind of performance. But yes, you sort of make it, you kind of suffocate yourself by raising the bar of internal assessment or internal checking criteria like this. So there are cases where people end up over processing more than what the customers ask for, and it starts hurting, like biting themselves. Like, so practically should need to not read too much into what the client expectations are there. Let's keep it as simple as the client is expected and deliver. Yeah, with some bit of cushion is fine, but this is too much. This is too much, and people do it. Fine tune things more than required. Defects and rework is still like, it's when you have defects, you have to end up reworking it. Rework means you're going to consume the raw material once again. You will be redeploying the same resources to do the same job which should have been done correct in the first place. You are prolonging the time, which is curse. Again, lean is not something. Lean is all about cutting down time. Rework is increasing it because you've made a defective product, then you kind of taking more time to fix it. That's a violation. Look at your lean, your first time right, your throughput yield, your rolled throughput yield. That will be an indicator that your process has defects or reworks there. This is where it becomes a call. This is the latest one which has been added to the list, which is skills. And I'm talking about unutilized skills. Now, there are a lot of people when they hire somebody, they want the best person to be hired. During job interview, I would expect you to know every part of the thing, in like everything in the world. I would expect you, the person, to be the best of the manager, have best of the managerial skills, and probably those questions would be framed that ways. But when it comes to real job work, uh, I would like to control them. That's bad. Well, when you really needed a clerk, you should have hired a clerk. You wanted, the expectations were that you needed a manager or somebody who can take decisions and do this stuff and that stuff. But when it comes to real world challenges, you define the rules. You tell them that this is what you need to do and stop thinking, do as I say. Well, you don't need it. You then should have hired a clerk. You poke your nose every now and then what somebody is doing. Practically when you do this, you are suffocating somebody. You are kind of poking everyone's in what somebody is doing. You are doing their job also. You're doing their job, but who is doing yours? Because your time is more valuable. You should have been utilized in creating some more business opportunities, doing something much better rather than, yes, it's good to have some bit of monitoring done, but too much. It's like when people become control freak, they end up doing over like controlling, which is unfortunately bad. Because you see, I've seen a lot of organizations where even to get a bill passed for $50, uh, there's a 7 or 8 level of approvals which are required even to get a bill passed for $50. It will be processed at 5 different levels, and finally the CEO will approve it before it gets passed. Well, I'm again, if you find that's good enough, well, unfortunately, it doesn't sound nice, because you are creating two types of waste: a waiting waste, because it's waiting for everyone's approval. All those 7 people will not be sitting at the same time for approving it. So creating a waiting waste, and you're creating unutilized skills also. So at least for a $50 bill, you should be able to uh, trust somebody higher up in the management, not up to the level of CEO. So CEO is also involved in approving a bill which is $50. Unfortunately, that's not a good company to work for. So you should delegate some bit of, yeah, there could be filtering done. There could be levels which can be created, that like, say, up to this level, somebody X person can approve. If it's more than this, then the Y person also involves in it. So you can create certain layers, but it can't be like for everything else everyone is required. Then why you needed those people? Like, if you had to approve everyone. So when I have step A, step B, if your job is audited by me and my job is audited by somebody else, and that person's job is audited by somebody else, then what is the purpose of having all these people in between when you can't trust them? So simple as that. Having too many check mechanism is when you kind of unplanned way of unstructured way of working it. So this is corporate curse. Unfortunately, people have this, and this also comes with some sense of insecurity. When people become insecure, they tend to kind of control this people, and they don't let people work. A good manager, good boss will always let people execute things and be there to help them when they need them. But unfortunately, that's a you as a boss will not be doing justice if you're not not utilizing the optimum skill sets of your people. So that's how it works. The different types of ways you have to it you can't remove all of these, but yes, it's a never-ending drive. You have to always keep finding things and remove it as much as you can, because you'll never attain a position where you can say, no, I'm done, it's okay. uh, the best people who understand this lean is the Toyota people. Toyota people say they have 5% of value added activity in their process. That's all. They say we are still have 95% of non-value added activities. This is what Toyota people have been able to achieve. That's what they still say. This is getting at 5% is the normal process. The real value added is a basic just bare 5%. So it's a never-ending drive because you always have a lot of junk. Some junk will be required out of this 95%. Again, I will still say 70% could be in case of Toyota. That's what I can recall is the essential non-value added. But they are remaining still 25% is the pure waste, which is still there. So I mean, what that's what I can recall from the last update or whatever we saw. But yes, uh, increasing you have to kind of continue squeezing out as much as you can. You can't just be really judgmental about these people. How many people do you need? Probably you needed 2 people in HR, you have hired 10. You needed 5 people in quality, you have 20. That bit of introspection will be required to kind of move some waste from here also. But yeah, but this is the first primary target, to kill the waste from here. So that's all about the basics of lean that we need to cover from the Greenville perspective. Yeah, any questions that we have and the things that we discussed? Anyone has questions?
So far, none, sir.
Okay. How about others?
Um, I just have one basic question about what I'm personally what I'm very much confused of is
Hmm.
how to formulate the charge, the statistics. Is there any way we can find like a template or a guide for that for MINITAB?
Yes. Is this? I think I shared this basic sample project. Did you receive that? Like,
Yeah, I opened that up.
yeah, so this has got like basically it gives you a layout of how a project would look like. Barring that, okay, let me give you some more stuff. You can look at this one. Also, everyone can have a look at this. Uh, Give me one quick second. There's some sample projects so that you have an idea about how the projects are done.
Oh yeah, yeah. Actually, we saw that it's. I'm looking for something like does MINITAB provide, say, a guide if I want to run chart, what do I need to click?
Okay,
Where can
that
I?
one. Okay, so if you were talking about the MINITAB path, is that are you referring to that?
Oh, there is stat quality tools run charts. Okay,
Yeah.
is that it?
So
Is that the
it,
address? I can find it.
yeah, so it is there in the if you check for the Minitab stats guide. I like think I shared Minitab stats guide with you all. In case if I haven't, then I will share it. Minitab stats guide.
Yes, please.
Okay, I'll share that like Minitab stats guide. You will be able to see where to when to click what, and that gives
Yeah,
you a
yeah.
little bit of idea. I'll share that file along with this Excel sheet. But for extra bit of projects, right? You can go to SlideShare if you want to get an idea about SlideShare.net.
Slide share.
.net is where you can find some sample projects just to get an idea how people have created and different projects. Some bit of Six Sigma projects are there, so you can have a it's a fair bit of idea. And Let me just open it up. It's taking time. I'm not sure whether has anyone been able to open slideshare. Okay, it's there. Now say slideshare.net. I go and find like say 6 Sigma projects. And there's some sample projects here. See, you can try out. Like, and just change your basic nomenclature here and there. You'll be able to find various sample projects. Some slides are there. Able to have a look at different people have submitted various templates. You can have a look at it. It gives you a fair bit of idea how projects are managed. Is it okay?
Okay, thank you so much.
Okay.
We'll take a look at it.
No. Anyone else has any questions? Because that's what we have for today. Like practically that's the last session, but yes, still you have any questions. So I will be sharing the MINITAB stats guide with you all. So you can have a look at this. I'll just make a note of it. MINITAB stats guide. It just tells you what path, what to click, what not to click, and all that stuff. It gives you the idea there. Any questions?
Excuse me. The MINITAB stats guide, you're gonna share in the chat.
Yeah. Give me one quick second. I'll just try to see if I have it here. MINITAB stats guide. Oh, all right.
Sir, do we still have one more session?
I'm sorry.
Do we still have one more session next week?
Like, no, this was the last session for Greenbelt.
Okay. Okay, can I know after we do all the computations, we will just base our decision based on the last topic that we discussed? Am I correct?
Yeah, so whatever I think there will be some mock tests that you'll be getting from the IMC, and based on that you will be able to go ahead with that.
But
So,
Mr. Satyaprakash,
yeah.
Mr. Satyaprakash, I think we
Yes,
will not have
certainly.
a good image for IMC. Huh? Every time we have to follow up with the link. Somebody has somebody is not able to log in. Somebody has saying that trainer is not available. We don't have a good image for IMC.
So, who have you been in touch with? Like, who's the point of contact? Who's like? I think everyone should be having their point of contact with IMC.
What is the case if we want to change the point of contact?
No, so whosoever is the point of contact, I can. So, do you have any classes? There were 4 classes, I think, which was scheduled for this batch, right?
Yes.
Yes. So, is there any other classes like so? If there is a confusion, I just want to understand, like, is there any confusion there? I can try to kind of coordinate with
that confusion
somebody
is
there.
happened last. That confusion is happened last Friday, na? That you sent me the email to me. Then I told that trainer is not available. His health is not good.
No, probably. So there was a miscommunication because of some other classes, though. So
No, that is not for
I was
that is
fine.
that is not the first time. Every time we have to follow for the link as well. Yesterday evening also around 10:30 I have sent a mail message that please provide the link.
Okay, can you tell me like who's the point of contact there for so that I can at least I know
Vishal
for
Dubey
sure.
is there.
Vishal. So and so I'll try to kind of coordinate with somebody else there who can so anyone who has any concern. So with this batch, what I can do is I can ask. Yeah.
And I don't know. Yesterday he replied my message that that link will be provided by tomorrow morning, and immediately within 5 minutes we got the link as well. Means what he is doing, I am totally not understanding.
Okay, so so as whosoever is like my point of like I coordinate with the I will be checking with them, and I'll ask them to speak with every participant to understand what went wrong, so that we can see practically it's important to make sure that your expectation, your whatever the reasons are there, the so if that's not getting met and there's some problem or miscommunication, that needs to be taken care of. So if there's I hope with respect to training, if there any feedback that you want to share, I'll be more than happy to take it. But from the rest of the things, I will definitely want to connect you with or ask somebody from IMC to coordinate with you all to understand what went wrong. If anything with respect to training is there, I'll be more than happy to take the feedback right away. So there's no problem there. But yes, with respect to anything else, be it the management, the coordination, and all that you have as a concern, I will definitely reach out to somebody and ask them to speak with every participant and understand what went wrong. Is there like are there any other trainings which you have already also lined up for?
Mr. Sase, this is
Yes.
Mehul.
Yeah.
Yeah, Mr. Sase, there is no doubt about your teaching skill and the quality of the training. Really, it's good. The contents are really great. And what we are looking for, we are having the another course like black belt, right?
Okay.
So whether you are going to conduct the same or some other trainer will come.
So what day is the black belt training starting? Is it the 7th?
No,
We
no.
don't know.
Till
We
we
I
don't
don't think
know.
we have the date already.
Okay, so I need to
No
I
date.
so okay. Give me like so what I'll do is I'll be like today being Friday, practically no one will be there like as it's no, it's an off day for them also. So I will be coordinating with I'll drop a message to the concerned person there, and we'll ask them to coordinate with everyone. So everyone in this batch to understand what is the concern. So I will ask with somebody who has been managing all the like which with whom I'm coordinating. So I will check with that person to see, make sure that everyone gets to speak with the person, so we have a clarity of thought as to what is your next training, what all is covered, and all that. To like if there's anything which needs to be understood and discussed, can be sorted out. So by tomorrow, I think everyone should be like somebody will be calling you from IMC to understand what went wrong and whatever is lined up, how we can manage it going forward.
for Mr. Sasi, what we are looking for now. Suppose there will be an exam, right?
Right.
So when it will be the exam, I already spoke to our coordinator and he told okay we will schedule within the next 1 or 2 day or it is based on our convenience. There is no issue. But what will be there in the exam? Do you have some idea?
They will be sharing some sample questions also. So I will be sharing another link also for you to prepare from
Hmm.
sample questions. So it doesn't mean that the we'll be out of touch. So I'll be sharing some additional stuff going
Okay,
forward also.
can you give us some brief like what kind of the exam, how many questions will come and what will be the period and
Honestly, like I would
where the
not have
before.
uh, no MINITAB would not be required in that. But yes, basically when we talk about those exams, I don't have the count of questions, like because like I'm not into that examination part of it. But they're multiple choice questions because I've seen their sample questions which they share with the participants when they want to prepare.
Yeah,
So
it is there on the website. They told just we have to log into the LMS or there is a
yes,
we have to.
similar questions are there. So the way those questions are there, similarly, say the language might be changed, the values will be changed, but more like the questions are similar, so you don't need Minitab for any of these.
Great. Yeah,
No,
okay.
but can you, Mr. Sasi, can you
Yeah.
conduct one session to make us preparation for the exam?
I have to check with IMC. So I like so that's what it give me time. Like I will be in which was dropping an email.
It doesn't require the full day, na? You can just give us the overview within half an hour or 1 hour.
So I have like so on it because I have not been part of their examination team. Like so, I'm just been into the training part. So even
Okay, no
that's why I
problem.
don't know how many
We will
questions are
discuss
there.
our, we'll discuss our
Yeah,
college.
so just let's give me time till tomorrow. So because I'll be post this session, I'll be sending out an email to the concerned person there with whom I interact. I'll be sharing your concerns, and I'll ask them to coordinate with every one of you so that if there is any question, any confusion which is there, that can be sorted out. That will see the priority is to make sure that whatever was your requirement when you got into this, is that being fulfilled or not. And we will always want that to be taken care of. So no hassles, no worries. Just give me time till tomorrow. Let me just speak with the concerned person and have this individual one-on-one conversation done with the concerned person. In case you're not happy with the point of contact, we'll have somebody else coordinate with you from IMC with whom you can interact.
Yeah, okay, sure. Thank you.
My pleasure, sir. So, and having said that, we always connected. So don't. So at any point in time, if there's anything which is required, I'll still be available. So that is not. It doesn't say that is the end of it. So yes, if you need help any point in time, when you're working on a project, real world challenges, again, please, you have my details. You will be able to be in touch for that. No issues.
Yeah, okay. Thank you.
Okay. So my pleasure. So sir, please just give me time till tomorrow. I will let me coordinate with concerned person, and they will be in touch with everyone to understand what is that's bothering you, and that should be the first priority to have that resolved. Okay.
Okay, bye. Happy
All right.
weekend.
All right. You too. Thank you. Thanks
Thank you,
everyone.
Mr. Sasi.
Thank you. Please take care of
Thank
yourself.
you so
Thank you.
much.
Thanks.
Thank you,
Bye-bye.
Mr. Prakash.